Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So guys, welcome to 9 days challenge where we are going to get 90 plus marks in just 9 days, and all you have to do is attend these lectures and that's it. That's it. No homework, nothing. Just attend the lectures that we are discussing, the questions that we are discussing in these lectures, right? So today we'll be doing aldehyde, ketones and carboxylic acids, which is a very important chapter, and it's a very lengthy chapter as well, right? So we are going to discuss firstly aldehyde, ketones, all the naming reactions, distinguish test here, some important reagents here which are usually ignored but they are asked, and we are going to see how they ask you questions in the exam, right? So everybody, do let me know in the chat box if your guys are ready for the class. And before you ask me, ma'am, how long this lecture is going to be, then my idea is around 4 hours. It will take 4 to 5 hours because it's like a very detailed one shot that I am taking today. It's not like you have to watch something else, ma'am. If I have seen aldehyde ketones, if you have seen aldehyde ketones from here in this lecture, trust me, you don't need to watch it from anywhere else, right? That's it. That's all you need to do. It's not a quick revision. It's nothing like that. It's in detail, to the point, yet like all the topics are being covered here, right? Okay, so that thing should be clear in your head. I will definitely give you break for your dinner, but be patient, because in these 9 days you have to be fully patient. The lectures are definitely going to be long, but you need to feel relaxed and have that consistency every single day. So everybody, write down in the chat box hashtag day 1 aldehyde, ketones and carboxylic acid, a very demanded chapter that you were asking me to take for a very long time, and that's what I told you that I'll definitely take. Don't worry about it, right? Okay, so now the first thing that we have is, I'll start from as if you don't know nothing about it, right? So if I talk about aldehyde, guys, what is aldehyde? This is a carbonyl group that you have. This is the carbonyl group, right? And if in one place you have alkyl, right? If here you have hydrogen, that is aldehyde. And if on both the sides you have R, that is alkyl group, that is called as ketone, right? So aldehyde and ketones are basically having carbonyl groups. In case of aldehyde, you have CHO group. In case of ketone, you have two alkyl groups in between which you have carbonyl group. That is why it is so important. It will be connected to so many different chapters. And I always tell the students, guys, if you ask me, ma'am, one very big question, ma'am, can I just do, ma'am, aldehyde, ketones and carboxylic acid from organic chemistry and marks will be there? Definitely not, right? Ma'am, can I skip aldehyde, ketone? Definitely not at all, right? Organic chemistry is totally interlinked, right? And this is the chapter from where you will see the connections with most of, like, hydrocarbons. You will see connection here. Alcohol, you will see connection here. You will see how aldehyde, ketones are prepared from alcohols, from hydrocarbons, right? From how alkyl halide is being connected to this chapter. So that's why it is the most connecting chapter here, right? That's why it is so important, right? Now let's talk about this thing, that when you talk about carbonyl group, talking about its hybridization, you have C double bond. This is like this. So you have total 3 sigma bond, 1, 2, 3 and 1 pi bond. And from chemical bonding, we know that whenever you have 3 sigma bonds, it is sp2 hybridization. And always in case of sp2 hybridization, what is the angle? The angle is 120 degree. It is trigonal planar in nature. It is trigonal planar in nature. You can't say, ma'am, it's not trigonal planar. Trigonal planar means in one plane, and all these angles, let's say this is 1, this is 2, this is 3. All these are in one plane, and all these will have 120 degree angles in between them. Now, if you see, there are two kind of sites here which will help you to identify which kind of reaction is going to take place here, right? What are these sites? This is nucleophilic site and this is electrophilic site. Ma'am, what is nucleophilic, electrophilic site? Ma'am, I don't know anything, ma'am. I'm not good in organic chemistry. Don't worry. This lecture is for you, right? Even if you're good, you're not good in organic chemistry, you will be able to understand everything from this lecture, right? So if you see nucleophilic, nucleo means nucleus loving, right? Nucleophilic site, that means the site that is electron rich here, right? Electron rich would want to go to electron deficient species. That's why it itself is electron rich. That is why it is a Lewis base. It is electron rich. If you see, oxygen here is electron rich. Oxygen is more electron negative as compared to carbon. So oxygen is electron rich species. That is the reason it is a Lewis base. Lewis base means it is electron rich, right? Nucleophilic, because it is rich, it would want to go to deficient site, right? So that's why it is nucleophilic site, right? Nucleophile will attack on this site, nucleophile. And electrophile that has electrons, it will attack on this carbon. So electrophilic site means Lewis acid, that means it is electron deficient. And always remember to where nucleophile will attack, where nucleophiles are going to attack on the oxygen and electrophiles are going to attack on the carbon. Nucleophile is electron rich, this is electron deficient, right everybody? Okay, wait a minute, no, electrophilic na are negative. Nucleophile is going to attack here. Yes, electrophile is going to attack here. Okay, it is opposite. Nucleophile, right, that is electron rich, is going to attack on the electron deficient species, right? That is why it is electrophilic. This site is electrophilic, right? That, and this site is nucleophilic site, where electrophile is attacking here and here nucleophile is attacking. That is very important. The nucleophilic site is which is electron rich, and where electron deficient species, that is electrophile, is attacking, right? So it itself is nucleophilic, right? Okay, tell me in the chat box if that is clear. Which species will attack where? Is okay. Don't worry. It's a 9 days challenge. Don't worry, I have planned something for you, right now just focus on this chapter, because I have not discussed this chapter on this channel, so I want to discuss this chapter in detail, right? Don't worry, I have planned something for your organic chemistry. You don't need to worry about anything, right? I'm going to change the game in next 20 days, and I'm promising you that, right? So don't worry about that, right? Now, IUPAC naming, guys, if you talk about IUPAC naming, just remember that if you talk about alkane, instead of E, you will have here al for aldehyde, right? Like methanol, propanol, butanol. And if you talk about ketone, instead of E, you will have on here, like propanone, butanol, right? That is going to be your IUPAC naming for this. Now let's come to the major part, that is reactions part, right? That is a major chunk of this chapter. That is, first we are going to talk about preparation from hydrocarbons. Now you will see how it is related to hydrocarbons chapter, right? You will have this revision. When you're doing aldehyde ketones, you will have this revision of hydrocarbons, alkyl halides and alcohol, that will run in your mind, right? Okay. So if you see, first is hydrocarbons. Hydrocarbons are what? Hydrocarbons are alkanes, alkenes and alkynes. These are the hydrocarbons, right? We are going to discuss all the different types of reactions here. If you discuss alkanes, in a case of alkanes, there is controlled oxidation. These are the methods of alkenes, and these are the methods from alkynes which you prepare these carbonyl compounds, right? And these are aliphatic compounds with aliphatic R ring is there, right? That means cyclic ring, aromatic ring is not there, right? Okay, so now we are going to talk about from alkanes. Alkanes, what? Alkane is CnH2n plus 2. From here you are going to prepare CHO group or C double bond O carbonyl group. That means either aldehyde or ketone you will prepare. And we discuss the preparation of aldehyde and ketones together only, because same kind of compound, same functional group will sometimes give you aldehyde, will sometimes give you ketone. Okay? Yes. Yes, everybody. Now, first thing is by controlled oxidation of alkanes, right? So if you talk about the first reaction from alkane is controlled oxidation. So whenever we talk about oxidation, you need to understand one thing here, right? Whenever I talk about oxidation, this is the chain that you must know, right? That will help you really in organic chemistry. If I talk about this is alkane, after oxidation, it will be converted to alcohol. After further oxidation, it will be converted to aldehyde or ketone. After further oxidation, it will be converted to carboxylic acid. Carboxylic acid. So this is the chain of oxidation that you have. And reverse is the chain of reduction. So why we are saying controlled oxidation? Because we don't want to have carboxylic acid. We want to have aldehyde or ketone. So that is why a specific reagent is used here, that is O2 with molybdenum oxide at 200 degrees Celsius and 100 atmospheric pressure. You don't have to remember as such temperature and pressure. Just remember that controlled oxidation of methane is going to give you methanol in presence of molybdenum oxide. That's it. Just remember this thing. And this reaction we have also discussed in hydrocarbons, right? Next is by reductive ozonolysis of alkene, right? This is from alkene. From alkene, firstly, we are discussing this very, very important thing, that is ozonolysis, right? Two kind of ozonolysis you have. First is reductive, second is oxidative. If you remember, in alkenes, we have discussed this, but ma'am, I don't know, ma'am, I don't remember. Don't worry, I'll again teach you that, right? So see, basically two things you have here. What exactly happens here? Firstly, I'll give you a simple trick to answer this, and this is very, very important. This is quite a very repeated question in your JEE, very repeated question, right? Based on ozonolysis. If you see, whenever you have a double bond, right, all you have to do is, in the reductive ozonolysis, break the pi bond, attach double bond O, double bond O. This will become RC. This is H. This is double bond O, plus this is CH2. This is CH2. This is double bond O. Or you can write it as this. Now here you have the preparation of aldehyde. This is H2CO, right? Now this is also methanol. This is your, any aldehyde can be there because this is CH2 group. Depending upon R, it will be different aldehydes. So all I have done in case of reductive ozonolysis is break this bond and attach double bond O, double bond O. You will have the answer for the corresponding aldehyde or ketone that you will have, right? And ma'am, what about the mechanism here, how it is formed? Let's talk about that. So what exactly happens in case of ozone? What happens? This bond will break, and here you will have O attachment of two oxygens. Here you will have attachment of one oxygen, and this particular ring that is formed, it is called as ozonide. That is the intermediate that is formed here. After this, what will happen? The breakage will happen, and hence you will have the formation of RCHO and HCHO from here, right? Okay, do let me know guys if that is clear, right? For the exam point of view, remember that ozonolide is formed here. Like if you see this case, I have told you this directly also here, na, that how it is formed. Achha, one more thing, ma'am, what about oxidative ozonolysis? Ma'am, what if I have oxidative ozonolysis? Then what is the difference here? Right, so I'll teach you that. Wait a minute. What if reductive gives aldehyde and ketones? Very good. Now, can you tell me, everybody in the chat box, what does oxidative ozonolysis gives you? Let us see if you can remember anything from hydrocarbons or not. You will see how this chapter is going to revise other parts of organic chemistry as well. Tell me, anything do you remember of that? Anything do you remember? This is RCH double bond CH2. right? 1 2 3 4. Now what we have done here is break the double bond here and attach double bond O, double bond O. Please don't show this kind of breakage whenever you have any proper in your subjective exam. This is just a trick that I am giving you, okay? So otherwise the bond shifting happens, but we are talking about the trick. So this is CH, this is CH, right? To this carbon H is attached. This will be double bond O, and this is already to this carbon, two hydrogens are attached. This will be double bond O. So this pi bond will break, you will attach double bond O, double bond O. That is the reductive ozonolysis, RO. Ma'am, now for oxidative ozonolysis, what we will do? We will, very good, carboxylic acids are formed, right? Let's see how carboxylic acid and ketones are. Very good, Sohail. Replace the hydrogen with OH, it gives acid. Which hydrogen? You have to replace that hydrogen which is connected to the carbonyl carbon. So this particular hydrogen will be replaced. This hydrogen will be replaced here. It's simple only. See, this is RC, and this is very frequently asked. Trust me on that. Organic chemistry, you feel it is tough, but when you start doing this with the help of these things, now you will find it quite easy only. Right? This is OH, this is OH. Okay, who will tell me this is an acid, carboxylic acid? What is this? H2CO3. It is carbonic acid. And remember, H2CO3 is again converted to, it is decomposed to water and carbon dioxide. Hence the final products here are this carboxylic acid and water and carbon dioxide, right? In books it is directly written that on oxidative it will give you this, right? Now remember one thing, in case of reductive ozonolysis you will use zinc. In case of oxidative you will use H2O2. Ozone you are using in both the cases. If you use zinc, then it is reductive. If you use H2O2, that means they are saying it's oxidative ozonolysis. Right? Okay? Yes. Only that hydrogen that is connected to the carbonyl. Other hydrogens you don't have to replace with OH. Only that hydrogen that is connected to carbonyl carbon, that's it. No other hydrogen you will replace here. Right? For example, this is the compound. Now let's see here. Firstly, I'll talk about reductive ozonolysis. This bond will break here. I will have R. This is C. This is R. And this will be double bond O. Right? Okay. 1, 2, 3, 4. It should be, this hydrogen should not be there. First case. This hydrogen should not be here. It is making it pentavalent, no? So it should not be there. Right? Then it is, break this pi bond. This carbon has two hydrogen already. This is double bond O. So it is giving you a ketone and an aldehyde, right? Methanol and a ketone in the reductive ozonolysis. When you convert it into oxidative ozonolysis, which hydrogen will be replaced? Can you see any hydrogen here? Any hydrogen connected to carbonyl. To carbonyl, one carbon is connected, other carbon is connected, one oxygen. Here you have two hydrogens, so it will be RC double bond OR, that is ketone only. And here it will be H2CO3. When you replace this with OH, that is going to give you H2O plus CO2. That will be written in the options, right? Okay. Right, everybody? Easy peasy. In place of, now remember this, for reductive ozonolysis, you can use zinc, you can also use methyl sulfide, that is Me2S also you can use here. This is for reductive ozonolysis. This is for reductive ozonolysis, you can use this, right? But in case of oxidative ozonolysis, what you will use? We will use O3 and H2O2 and H2O2, right? Okay. And in this case, because always there should be a double bond, that's why this, if ozonolysis is occurring, that means there must be a double bond in that compound, only then ozonolysis will take place, right? Next is Next question, this oxidizing, this ozonolysis was a very important reaction. Remember this. Very high chances you will see a very simple question based on ozonolysis in your exam, right? Second is, you have bi-oxidation of alkenes. Ma'am, what is the difference in oxidation and ozonolysis? Let's see that difference. Okay, sometimes the product can be same, but the reagents are so many reagents you have for oxidation. That's why you need to see this very carefully. Strong oxidizing agents like you have K2Cr2O7 or hot alkaline or acidified KMnO4 cause oxidative cleavage in substituted alkene to form ketone or carboxylic acid. What do you mean by that? It is same as, I would just write it as same as oxidative ozonolysis. Ozonolysis. Same answer is given by oxidative ozonolysis, or you have K2Cr2O7 simple, or you have hot alkaline or acidified KMnO4, right? They all will give you same answer. What are the three things? Same answer will be given by KMnO4 if it is hot or acidified, right? Then K2Cr2O7, then you have O3H2O2. They will give you the same answer from alkene, right? Same answer will be given, right? Okay, yes. Understood? Now if you see this here, right, acidified KMnO4, it is going to behave like oxidative ozonolysis only. So what you are going to do, you are going to break this bond, attach double bond O here, right? Okay, this double bond O you have attached here, there will be one hydrogen as well, which will be converted to OH, and that's why you have COH and C double bond O. Understood what why I'm saying? I'm saying break the double bond. I'll just show you this here. See, break the double bond, right? After that, what you have to do? Attach double bond O. Okay? So you'll attach double bond O. Just like in oxidative ozonolysis, see if there is any carb. This is carbonyl carbon, it does not have any hydrogen. This carbonyl carbon has one hydrogen, right? Because tetravalency will only be completed by then. So this hydrogen will be replaced by OH, and that's why you have COOH here, and this is C double bond O. That is why this is the answer that you are having here. Similarly here, acidified KMnO4, same. Even if it is written, even if they have written K2Cr2O7 or they have written O2, O3 in presence of H2O2, same answer will be there, right? So here also what you have to do, break the double bond. This is the double bond. I'll break the double bond here. When you break the double bond, attach double bond O, right? Is there any hydrogen here? Is there any hydrogen? 1, 2, 3, 4 carbon bonds are completed. Tetravalency is completed. 1, 2, 3, 4. 4 bonds of carbon are completed. It does not need any hydrogen to complete its bond, right? So that is why it will stay as it is, and this will be your answer, right? Okay. Yes, everybody. Can we not use weak oxidizing agent? You can definitely use that also, we'll talk about. But here we are, because we have discussed oxidative ozonolysis, so that's why I'm discussing this here only, that oxidative ozonolysis, or you have K2Cr2O7, or you have acidified KMnO4 with alkene, they are going to give the same answer. Okay, that's why I'm discussing this here, right? Okay, yes. Tell me everybody, right? Now next is Wacker's process. Let's understand what is Wacker's process. So if you see from alkenes only, alkenes can be directly be oxidized to corresponding aldehyde or ketone. You'll directly oxidize them to corresponding aldehyde or ketone by treating them with PDCl2 PdCl2 containing catalytic amount of CuCl2 in the presence of O2 or air. And this question also is very important. This reaction, this reagent, directly they ask you wacker process. Wacker process. In wacker, what is there? Kids they use walkers, no? Kids use walkers, right? So you can remember this, like kids use walker, right? Kids use walker. So here wacker, in terms of kids, you can remember this by ketone, right? And here from D you can ID, you can remember this by aldehyde, right? Or aldehyde they will convert it into, right? And what they convert into aldehyde, they convert alkene to ketone or aldehyde by using, right, PdCl2 and CuCl2. PD and CuCl2, right? So this is the alkene that you have. With the same number of carbon, you will have aldehyde. This is the ketone. This is the alkene. With the same number of carbon, you will have ketone, right? So this is how it is done. With the same number of carbon, you will have the formation of corresponding aldehyde and ketone here. Except ethene, any higher alkene will give ketone. This is a very important point, that which of the following, ma'am, which will give aldehyde, which will give ketone? Only ethene is going to give you ketone, others are going to give you, only ethene is going to give you aldehyde. Only ethene will give aldehyde, others are going to give you, other alkenes are going to give you, higher alkenes are going to give you ketone. Just remember this point and remember the reagent here, that is PdCl2, CuCl2, right? Okay, yes. Tell me everybody, is that clear? Is that clear? Right? Now let's talk about this thing here, that is oxo process, right? Next process is oxo process. It is called as carbonylation as well. Let's talk about what is this oxo process and here what we do. Again, this is from alkene, we are preparing aldehyde or ketone. But here how we do it, right? Alkenes react with water. What is water gas? That is CO and H2. That is water gas. CO plus H2 is the water gas. This is water gas. Okay? This is water gas. So alkene reacts with water gas at high temperature and pressure in the presence of cobalt carbonyl catalyst. That is cobalt carbonyl catalyst is there to give aldehyde here. And what kind of aldehyde will be given? Let's talk about that. You have RCH-CH2. In this case, with one extra CHO group is from this, it will from CO and H2, it will form one CHO group that will be attached here on either of the positions. It can be attached here, it can be attached on this position as well, right? And this is also called as oxo process, carbonylation, formylation, right? Here it's not like, ma'am, which will be the major product, both are formed in the same ratio, right? Okay, so one CHO group is attached here, either on this side or on this side, this will be attached, right? Okay, understood? And remember that this pi bond will break. CHO, if it is attached here, hydrogen will be here. If CHO is attached here, then hydrogen will be present here. That's how it is done. Okay, and here again, what is the reagent? Everybody write down, learn it here only in the class. Ma'am, one, show the last slide. This one, you can see this over here. Yes. Tell me everybody. In the chat box, I can see very few. It started off with very high energy. So many students were there, but you can see the students are dropping, and this actually shows the reality of students. I say you get scared. How will I be able to compete with so many students? When you realize the competition is not that much, only few students are dedicated here. They will watch, they will see, oh, ma'am has started something new, I'll join. Then they see, ma'am is not giving me some medicine which I can eat and I can just, vomit it out in the exam. No medicine I have to teach you in detail. And very few students will have that patience to stay here. That's why don't get scared of your competition, because it's actually not there. Because these simple things very few students will learn, right? That is the thing. Yes, chalo. Now let's start with this thing. What is carbonylation? Carbonylation, CO, CHO is attached. Water gas is used in presence of cobalt carbonyl complex. That is carbonylation, where CHO is attached here. Right? Okay, sure. Those who are Sigma batch students, they can watch the recording of this, right? Yes. Okay, now let's see this. Now this is also otherwise all the reactions are quite important, but there are some reactions which has like 99.9% probability to be asked in the exam, right? Okay, so let's see this question here. Here students ask, ma'am, is GOC important? These kind of reactions shows you how GOC is important to you, right? So we'll talk about that. I'm going to show you the application part of GOC as well here. See, the reaction takes place in presence of, do you remember acid catalyzed hydration? What was there? We used to form carbocation here firstly, right? So similarly here, when you have acid catalyzed hydration, you only use acid and water. But in this hydration, you has 1% HgSO4. Mercuric ion is also used here. So what we will do? In this case, you will have the formation of carbocation and carbocation, because both are same. So that's why one pi bond will break. And you will have the attachment of hydrogen on one side, that will form CH2, and this will be the carbocation that you have, and after the carbocation OH will be attached here. Okay, just remember that firstly a stable carbo, because this is same. See here, whether you form carbocation here or you form it here, that is the same thing, right? Whether you form carbocation here or you form carbocation here, there is no difference in that only, right? So you can do anything, right? So to one where carbocation is formed, OH negative will be attached, and to the negative part H will be attached. So it will be CH2 and OH, right? Tell me this step is clear or not. Can I see this here? Isn't it enol? Isn't it enol? Isn't it enol? And now how many of you remember tautomerism? How many of you remember tautomerism? Achha, be very frank with me. Tell me in the chat box how many of you have no clue about tautomerism, because I understand some students are those who have just gone to school. They just had some simple board tuitions. They had no idea about class 11th, right? So I want to see if those students are also present here so that I can also tackle them. Those who know what is tautomerism, then tell me what will be formed here, right? Okay, those who know what is tautomerism say yes, 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 yes. Those who don't know what is tautomerism say no in the chat box so that I can clearly see. Okay, those who don't know, I'll give you a simple trick here. Okay, and trust me, you will find it, you will be like, ma'am, it was so easy. It was such an easy thing, ma'am. I was getting scared of this thing. Now, application part of tautomerism I am going to teach you, right? Because full tautomerism I have already taught in one complete, I have taken 3-hour GOC one shot. I have taken there, I have not taken it, but don't worry, right? You can see my GOC lecture of isomerism. There tautomerism I have taught you in detail, but still if you want the short of it, I'll tell you what exactly we do here, right? Okay, see here what I'll do, the trick is from oxygen, write 1, write 2, write 3. What you have to do is shift the double bond from this to this. I'll just write it as it is. This is CH2, this is double bond, this is CH, this is OH. So what I will do, I'll shift the double bond here to this side. Double bond will be shifted here. Double bond will be shifted here. And this hydrogen will be shifted to this position. So it will be shifted here. This hydrogen will be shifted here. So here you will have CH3. Here you will have CH3. Isn't it aldehyde that is formed here? Can you see what I have done? Nothing. I have just done 1, 2, 3. Basically, tautomerism is shifting of hydrogen. Right? It is keto-enol tautomerism or keto-aldo tautomerism as well. It is converted to aldehyde as well. Right? So you can see this over here. What I have done, 1, 2, 3 you write. Then from oxygen you start 1, 2, 3. Right? Then this 2, 3 double bond will be shifted to 1, 2 position, and this hydrogen will be shifted to third position. That's it. What I have done, I'll just write it here as well. Shift double bond to which position? Shift double bond from 3 to 2 to 1 to 2 position. Then shift hydrogen we are shifting from 1 to third position. That's it what we have done, nothing else. It's quite simple, isn't it? Okay, so now you will form this yourself. Tell me what will be formed here. Do it yourself. This kind of question they ask you in the exam. Such a simple question this is. This is mercuric acid. From this reagent they will not give you, hey, this is Kucherov's reaction, do tautomerism. They will not tell you that in the exam hall. You will have to identify the reagent yourself. You will see this is acidic conditions. Okay. This is Hg2 positive, because I have seen, I was doing practice session in the Sigma batch, and I have seen one of the students told me that this is, ma'am, oxymercuration, demercuration. So these kind of mistakes you can do easily. Oxymercuration, demercuration, you use mercuric acetate in that. This is HgSO4 you are using, Hg2 positive ions. And in that case, you have, and here you have alkyne in acidic conditions. So this is hydration only. So firstly, tell me, you have this thing. Two possibilities are there. Which carbocation is more stable? Tell me. Should I have carbocation here or here? Blue or green one? Tell me which one is more stable. This one or this one? Let me see how many of you are good in... this is repetition only, Rasik. This is repetition only. This is another example of Kucherov reaction only. That was first example. That was a simple example. This is another example. So it is repetition only, right? Tell me. Whether this one is more stable or that one? Red one? Tell me why. Those who know GOC, they will be able to tell me. Those who don't know GOC, watch I have done GOC in 1 hour as well. You can, if you don't have time, go and watch that 1 hour session of GOC. Everything will be revised very quickly, right? Do that. It will help you a lot, right? And 3 hour session also I have done for GOC. You can also watch that. If you want to go in like total detail, I have done like 15-16 hours as well of GOC. It totally depends, but everywhere it's just that examples will be more. In 1 hour session, examples will be less, but everything important is there. So if you see here, this is plus effect. Because of this plus effect, whenever you have a carbocation, now always remember, I tell my students, you have two things. If you have a carbocation, it's like money. If someone gives you money, you are happy, right? Carbocation is like money, and carbon ion is like stress. If someone gives you stress, you are very sad. So to carbocation, when you give them electron, it is happy, it is stable, right? When you take away electron, it is sad. Here it is opposite. When you give the electrons, it is sad because you are giving them stress. When you take away the stress, it is happy, stable, right? So this is what we should know, that this is stable because of its plus effect. So this carbocation will be formed here. So hydrogen will be attached here and OH will be attached here, and this is nothing but this is enol, right? This step is clear to everybody. This step is clear. Money and stress, yes. Okay, that's how you should remember. Otherwise, organic chemistry is going to take away all the money and give you too much stress, right? So enol, this is because it is enol, alcohol for ol, this is enol. Now tell me what will be formed. From oxygen, I'll start with 1, 2, 3. 1, 2, acha, here because we have done it already, so it will be replaced. 1, 2, and this is 3, right? Now here what I will do, this is 1, 2, 3. Tell me what is the trick. Ma'am, kindly do one thing, ma'am. What is that? Ma'am, kindly take double bond to 2, 3, to 1 position. That is here. Ma'am, shift hydrogen here. Isn't it ketone that is formed? Isn't it propane that is formed? Right? Isn't it propane that is formed? Right? Propane, I am saying propanol that is formed. Right? Methanol cannot be formed from the above reaction. Why we are saying methanol cannot be formed? Why this cannot be formed? HC double bond OH. Why this cannot be formed? Tell me. For this to be formed, there is no, if you remember Tautomerism, you will be able to tell me this thing. If those who remember Tautomerism, they'll be able to tell me this thing. Ma'am, because in Tautomerism, the condition is that alpha hydrogen should be there. If I convert it into enol form, is there any enol form of this? Is it possible to make it like this? OH, this is H, where this H is coming here, where this double bond SA? Hanging, this double bond is hanging. This enol form is not possible only here. So how come methanol is possible? When enol form is not possible, so this thing is not possible only, right? Because keto-enol tautomerism will not take place there, right? Okay, if you have this here, HC, that's why it is not formed, hai na? I told you that. Now, next is hydroboration-oxidation, and that is from alkynes. Now from alkenes, how many of you will tell me? Tell me. Yeah, very good, Sabra. There is no alpha carbon to procedure to hydrogen. Yes, definitely right. There is no alpha carbon. There is no alpha hydrogen. Then how tautomerism is possible? Enol form is not possible. So methanol formation is not possible. They can ask you this. Which of the following things cannot be prepared from Kirchhoff reaction? Answer will be methanol cannot be prepared from the Kirchhoff's reaction. Right? Now tell me, in the hydroboration oxidation, I'll just write this here. In case of alkene, you have the preparation of alcohol. There also we used to do anti-Markovnikov addition. If you remember, this is, let's say, double bond. Let's say this is CH3, this is CH, this is CH2. When it is converted to alcohol, anti-Markovnikov always means negative part to more number of hydrogen. So negative part will be over here, right? So here you will have the formation of 1 degree alcohol always. But that was in case of alkene. We are asking about aldehyde and ketone. In aldehyde ketone, alkene, see, from alkene alcohol is formed. That's why you have discussed that reaction in preparation of alcohols. You have discussed that reaction in hydrocarbons, in the reactions of alkenes. See how they are interrelated to each other. Now this is anti-Markovnikov rule. Same thing, same reagents, everything same. The reactant is different, that is alkyne here. So let's see what will happen here. So you have alkyne, anti-Markovnikov addition. Tell me what you're going to do here. These are the reagents, B2H6, H2O2, OH negative. This is hydroboration. This is oxidation part, right? This will form RC double bond CH. Pi bond will break. This pi bond, I have break one pi bond. OH negative, negative part is attached to more number of hydrogens. More number of hydrogens are over here. So OH is attached here and H will be attached here. This is anti-Markovnikov addition. Tell me. This is anti-Markovnikov addition. Isn't it? Now tell me about one more thing. Tell me about one more thing. This is enol. Isn't it? Now can I do the same thing again? Ma'am, same tautomerism again, ma'am? Yes, again. See, it's how it is related. 1, 2, 3. What I have to do here? You just have to RCH This double bond will shift here, it will form this thing. This hydrogen will shift on the third position, that is on the alpha carbon, that will be CH2, and hence you will have the formation of this as your product, that is aldehyde. And always in this case, aldehydes are formed, ketones are not formed, right? This you will see this here. Terminal alkynes give aldehyde and other alkynes will give ketones. Now, ma'am, why terminal alkynes give aldehyde? Why terminal alkynes will never give ketone? Why terminal alkynes? Because always there will be formation of enol on the terminal position only. That's why terminal alkynes are always going to give aldehyde. If you have, let's say, if you have R here as well, right? Then in that case, obviously that is going to give you ketone, right? If you have, let's say, R here, then this will be double bond, this will be OH. Then this will be converted to, this is single, then this will be converted to double bond. This will give you ketone. Okay? Understood? Right? Yes, everybody? How other alkynes are going to give you ketone? Tell me, everybody, in the chat box. Yes, Bhanusai, your notes will be provided to you. And short notes also, don't worry, we are coming up with something for your revision as well. From the short notes as well, right? Don't worry about that, right? Organic chemistry, I will do like this, right? Revision, you will be glad how I'll do organic chemistry, inorganic chemistry, physical chemistry. Revision will do it one day each. Don't worry about that. Revision, we have thought about it, right now just focus over here, right? So if you see this in this particular compound, what you will have, this is nothing but this is acidic hydration. So this double bond you will have, this is CH3 CH2 CH3 CH2 C triple bond CH. Here firstly it is going to form a carbocation. That which carbocation will be formed? That has more inductive effect is there, right? More hyperconjugation is there, right? So this OH will be attached here because this is the carbocation, right? Now this is enol form, this will be converted to keto form, right? So this is 1 2 and this is if you see, that will be 3. Okay, 1 2 3. So in this case what you will have, this will be CH3 CH2, this is C double bond O, this is CH3. That is keto form that you have. Okay, wait a minute. CH, wait a minute. C double bond O, yes. Okay, so that is A is the correct answer here. Right, everybody? Understood? Yes. Ma'am, please do video on topics deleted. Okay, definitely I'll do that. Okay, if you're confused about it, I'll do that. Right, I'm going to give you, if like I have seen some students getting confused in P block as well. And this is what I wanted to know from you as well. I am confused in one thing, and that I want to know in the chat box, in the comment section after this end of this marathon. I'll want to, this is your opinion that I want to know, right? See, we are left with biomolecules, amines, and P block, right? And I want to finish all of them in this 9 days challenge. Because after that, I'm going to do like your quick revisions. We are going to start the revision sessions, right? But before that, I want to know, do you want to do P block? Like, do you want me to do P block here or not? Right? Because that I'll do in detail then, right? So because I have seen students getting confused in that. So two options are there. One is amines on different day and biomolecules on different day. The other option is amines and biomolecules on one day, and P block and quantitative analysis that on one day, right? Okay, so these that's totally your choice, right? how you want to do it, right? If you have that much capacity of sitting here for 6-7 hours, then I'll teach you in one day amines and biomolecules, because those are small chapters only. Aldehyde ketone is a big chapter. That's why I have dedicated one day for this chapter. But I want to know from you as well. I prepare all the slides for you. I am here for 7 hours, right, sitting there, and no student is there. Then I don't feel like, teaching. Then I feel like, why am I doing that, right? Even I get demotivated like that, right? So what I want is, I want your answer for that. And my next two marathons are going to be on Monday and Wednesday, right? Monday and Wednesday will be those days where I'm going to take chemistry session at 6 p.m. itself. So you can free your slot for those 2 days, right? Okay. Now let's see preparation of alkyl halides. Let's see preparation of alkyl halides, right? Okay. So from alkyl halides, how it is prepared. So these reactions are also, you must go through them once, and we'll talk about these reagents. What are these reagents? What is KOH aqueous and KOH alcoholic? Tell me, what is the difference in KOH aqueous and KOH alcoholic? Who will tell me the difference? KOH aqueous and KOH alcoholic. So in this case, what happens? OH replaces halogen. Halogen is replaced by OH simply in case of aqueous. In case of alcoholic, dehydrohalogenation will take place. That is the difference between this aqueous and alcoholic. These little small, not dehydration. For dehydration, we have concentrated H2SO4, right? This is dehydrohalogenation. I'll just explain you that what we have here. This is, for example, you have let's say CC, this is X, and this is, let's say, hydrogen. So what will happen? Halogen, and this is hydrogen, it will shift here. You will have the formation of alkene. This is this is dehydrohalogenation, right? Okay, this is what we do in case of alcoholic. In case of aqueous, now these are the small things where students get confused in the reagents, and they do end up doing wrong in the exam, right? So aqueous simply means this will be replaced by OH, this will be replaced by OH. Now remember one rule of chemistry: one carbon can never handle two OH atoms, two OH molecules. It can never handle. Whenever you have situation like this, always what will happen? OH will be taken, and here what will be there? Here what you will have? Here H will be taken, and this will shift here. And what you will have? C double bond O is formed. So whenever you have on one carbon, you have two oxygen atoms, C double bond O is formed here. So how it is converted to this one, I'll just show you that, right? So if you see this here, okay, see this. This OH will be taken out, this H positive will go, and here you will have C double bond O and H. That's how aldehyde is formed from geminal dihalide. Geminal means on the same carbon when you have halogens, right? Okay. So here if you see, remember that terminal geminal dihalides, they will give you aldehydes, while non-terminal are going to give you ketones, right? How they are going to give you ketones? Let's see that. Same, everything is same here. You have OH, this will be taken out, this will be taken out. Here you will have double bond O, and that's how you have the formation of ketone, right? I would not advise you to remember these things because you can't remember. See, let's be frank, right? Let's be very practical here. You can't remember these lines, guys. But you can remember one thing, that aqueous KOH has this rule, right? And one carbon can never handle two OH. These things you should remember. right? You should not cram that when I have geminal dihalides, aldehyde ketone is formed. Nobody is asking you to do that. And that is not how organic chemistry is studied, right? So let's see this here. The question, next question is, identify the compound X in the sequence of the reaction. Okay. Now, this particular sequence, I'll tell you how to do this. Here you have CH. What will happen? You have Cl2 and H mu. Whenever you have Cl2 H mu, if you remember, this is a very famous reagent for one thing. I don't know if you can see that you are using the same reagents again and again. Can you see that? Haven't you used this reagent? Haven't I told you before itself? Those who have not watched me anytime before, it's okay. But I want to tell you now that Cl2 in presence of sunlight, or you have Br2 in presence of sunlight, or you have N-bromosuccinimide, all these are free radical mechanisms. And you know what they are going to do? They are going to replace the allylic or benzylic hydrogen with the halogen, right? What I am telling you, these are going to substitute allylic or benzylic hydrogen. Now, who are those students who don't know what is allylic and benzylic? Tell me, who have no idea about allylic and benzylic? Guys, see, when you have C double bond C and you have just give me a second. Okay. See, you have, when let's say halogen or any OH, anything is attached to your substituent is, I'll write substituent. I'll write it as X. Okay, when your substituent is attached to the double bond, this is called as vinylic. Okay, when next to the double bond you have carbon, then the substituent is attached, that is called as allylic, right? And what is arylic? Arylic, A-R-Y-L-I-C. Arylic is when it is attached to the benzene ring directly. And when it is not attached to the benzene ring, but to the next to the carbon, which is attached to benzene ring, then it is called as benzylic. Now, can you see these three hydrogens? If you see this over here, this carbon is benzylic carbon. Can you see that? This carbon is benzylic carbon. So this reagent has a rule that always it will substitute the hydrogens of this benzylic. But you know what is the interesting part? The interesting part is it will not substitute 3. It will substitute only 2 halogens. It will substitute, wait a minute, I'll just make it here, right? This is actually written in your NCERT directly. This will Cl, and this is 1H. After reacting it with H2O, what will happen? Or they can also use KOH aqueous. Then also it will be the same thing, right? This will be replaced by OH. Now OH is not stable. This will move from this side, and hence in the end you will have the formation of benzaldehyde, C double bond OH, right? So what is the intermediate X? Intermediate X is CHCl2. This is the intermediate X. This is where students get confused. Ma'am, whether it's CH2Cl or CCl3, most of the students, they pick CCl3, right? But it is actually CHCl2, right? Okay. Yes, everybody. This can get confusing here, right? Now, next is preparation from alcohols, right? Dehydration taking place after diol. Yes, very good. Diol is formed if there is geminal diol, always dehydration will take place, because one carbon can never handle 2 OH atoms, 2 OH molecules, right? Okay. Yes, right. Okay. Because see, if 3 chlorines, see, one thing you need to understand about chemistry, right? If you see this now, this mechanism we have formed, right? It's not like the reactant told us that I'm reacting this way. What we saw that from this you are having the formation of benzaldehyde. That is only possible if you have this situation, because if all the three chlorine all the three hydrogen atoms are replaced by chlorine atoms, in that case you will not have the formation of benzaldehyde. It will form C double bond O Cl or C double bond O OH. This thing acid will be formed here, right? So that is not getting formed, it is CHO, it is not benzoic acid. That is the reason. Okay, we predicted that if this is the answer, then this should be the intermediate here, right? Then obviously there are other ways of, then we scientists, not we, obviously the scientists, then they obviously by NMR studies and all, they okay, they analyze that, okay, this is the intermediate, that is final. From the energy diagram, everything is there, right? So preparation from alcohols. Now let's talk about from alcohols. There's so many reagent, PCC, PDC, Collins reagent, Jones reagent. Let's talk about that. Which is strong, which is weak, which is strong oxidizing agent, which are weak oxidizing agent. Right? Okay. Now, if you see this here, PCC, ma'am, do I have to remember this structure? No. Just remember that PCC, that is pyridinium chlorochromate. PDC, that is pyridinium dichromate. These are weak oxidizing agents. Collins reagent, that is nothing but chromium 4 oxide with pyridine in dichloromethane. Right, when you have CrO3, simply you can write it there. Jones reagent is CrO3 in presence of dilute sulfuric acid, right? So all these are, if you see, all these are mild all these are, wait a minute, all these are some oxidizing agents. These are not mild oxidizing agents. I'll just give you the list of mild oxidizing agents here. Wait a minute. I'll directly give you the list of mild oxidizing agents only. Oh, what is happening? I'll just give you the direct list of mild and strong oxidizing agent. Mild oxidizing agents are like PCC, PDC, CrO3 neutral medium, right? That is mild oxidizing agent. Strong oxidizing agents are KMNO4 in acidic medium, CrO3 water in H2CrO4 in acid, right? Then Jones reagent, that means CrO3 in acetone and sulfuric acid, that is Jones reagent. K2Cr27, all these are strong oxidizing agents, right? So we'll talk about how we are going to prepare these things in strong and weak oxidizing agents, right? So firstly, let's talk about mild oxidizing agents. In the end, I'll give you a simple chart. You just have to remember that chart. Okay, in the end, I'll just give you that simple chart. Right now, focus here. If you talk about mild oxidizing agents, primary alcohol is converted to aldehyde, right? Because here mild oxidizing agent, what will happen? This will be eliminated and here it will be double bond O, it will be converted to aldehyde. 2-degree alcohol is converted to ketone because again on carbon and oxygen this hydrogen is eliminated. You have this double bond O, it is converted to ketone here, right? 3-degree will have no reaction because there is no hydrogen on this carbon, that should be eliminated. Here you had this hydrogen on this carbon, that was eliminated. Here you had this hydrogen on carbon, that was eliminated. So now you don't have any hydrogen on the carbon to be eliminated, so and that is the reason there is no reaction here. There is no reaction here, right? Okay. See. Now strong oxidizing agents of primary. primary alcohol, what will happen? You have the formation of CH3C double bond OH. Just convert this hydrogen to OH. That will give you carboxylic acid, right? So that means primary will give you carboxylic acid. Secondary, what you had here, you had the formation of ketone. On further oxidation, tell me, is there any hydrogen attached to this? Any hydrogen attached to the carbonyl carbon? Can you see this over here? Any hydrogen, guys? Tell me. Any hydrogen that is attached here? Any hydrogen, guys, that is attached? I can't see any hydrogen here. So that's why it will be ketone only, whether it's mild, whether it's strong, it will be ketone only that is formed, right? Then tertiary, even mild was not giving any reaction, so strong is also not giving any reaction. Okay, then let's talk about copper at 573 Kelvin, or you can say 300 degree Celsius, right? What you have here, primary will give you aldehyde, secondary will give you ketone, but tertiary will not show any reaction. It's not true here. Tertiary is going to show the reaction. It is going to, what it is going to do, OH will be taken out here, and hydrogen of beta carbon, not alpha, beta carbon hydrogen will be replaced here. So this hydrogen and this OH will be eliminated. You will have the formation of double bond here, right? Okay, I know so many reactions, ma'am, you have given us. Acha, now we will make a table here. We'll make a table here and you will tell me which all will be formed, right? Okay, simple. You don't have to go through all those slides. Okay, simply you just have to remember this slide that I am writing now, right? This is the reagents we are talking about. This is mild, this is strong, and this is copper, right? Okay, that is copper, right? Tell me, shall I write it or you will help me write it? Will you help me write it? Who will tell me? Tell me. Acha, this is alcohol. This is alcohol. What kind of alcohol you have? Right? I'll just write here alcohol. Three kind of alcohols you have: primary, secondary, and tertiary. Right? There are mild oxidizing agents, there are strong oxidizing agents, then there is copper at 300 degrees Celsius. Right? What we have discussed, 1 degree alcohol, yes. Ready for this movement? Yes. Now you just have to tell me, fill in all the blanks here. Okay, I'll just write A, B, C, D, E, F, G, H. You'll have to tell me what is A, what is B, what is C. This is a quick revision. A, this is B, this is C, D, E, F, G, H, I. Tell me everybody in the chat box, one by one, what is A? What is A? Tell me everybody, what is A? Everybody, I want to see your energies in the chat box, right? Let's make this engaging. What is A, everybody? I'll wait for one more second, otherwise I'll just fill this all myself only. Yes, 1 degree is going to give you aldehyde. With the 2 degree alcohol, what is D? 2 degree alcohol is going to give you ketone. And 3 degree will not show you any reaction. Now tell me what is the answer for B, E and H. What is B? 1 degree alcohol, when you have strong oxidizing agent, it is going to give you what? Very good, very good. 1 degree alcohol, when it is strong oxidizing agent, it is going to give you what? Ma'am, it is going to give us It is going to very good, very good. Ketone, ketone, ketone. That is good. D is ketone. D is ketone. That's good. That's good. That's right. Yes. What is B? What is B? B is carboxylic acid. Very good. Carboxylic acid. Carboxylic acid. What is E here? What is E? E is always going to be ketone, whether it's primary, whether it's mild or strong, doesn't matter. H. Will it show any reaction here or not? H will show any reaction or not? H will show any reaction. B acid, ma'am. Very good, Sabri. Very good. Rasik, Sai, Pri, Shiva. Very good, Kavya, Maheshwari. Very good. Awesome, awesome, awesome. Very good, Suhail. Awesome. So happy that you guys, very good, very good. No reaction, ma'am. No reaction, ma'am. Even here, ma'am, no reaction. Acha, now you have to tell me about this one. Now you have to tell me about this one. What is going to happen in this case? What is C? What is C? See, for 1 degree and 2 degrees, copper is going to behave like mild only. So answer will be same as mild. It will give you aldehyde and it will give you ketone here. So it will be same. But what is this I? Why this is so different? Let us see who can answer me. What is this I? Let's see who can answer me. What is this I? What is going to be here? What should I fill here? Very good, aldehyde ketone. C is that. Very good, very good. Yes. Now answer me, what should be I? Very good, Pri. Very good, Adon. Maheshwari. Good, awesome. Yes. Aldehyde ketone, alkene. Very good, Suhail. Kavita, Siva, Ria, Tanuja. Awesome, awesome. Pri. Very good. Awesome. So that is alkene. That's good. Right? Now just remember all of this for your exam. Right? Remember all of this for your exam. Now, this is something that is going to, I don't know if this is not mentioned as such in your NCRT. All this was mentioned in your NCRT. But this thing is, I think maybe those who have just prepared for board, maybe they will do this for the first time. Right? So here I need your full attention. And also let me know, undergo elimination in alkene. Very good. Now, if you have like Ultra Pro, like iPhone launches its phone, iPhone 17, iPhone 17 Pro, iPhone 17 Pro Max, right? So this is Pro Max, Ultra Pro Max level, right? One was mild, one was strong. Now here you have strong, but under very drastic conditions. Drastic conditions means something different is going to happen here. Right, so we'll talk about that something, right? Okay, thank you, Kumari, thank you. Right, so now let's see this. You have oxidizing agent and we are heating it. Now I am not using oxidizing agent simply, I am heating it under drastic condition, right? That means drastic means I am using KMnO4 in acidic medium, but I am saying I am heating it as well. So this makes it drastic condition, right? In drastic condition, tell me what happens. It's like your mom. Have you ever been slapped by your mom or not? How many of you? Tell me yes or no. How many of you have a slap by your mom, right? So one mom is, sometimes mom is completely mild. Mom is like chill pill, she is not scolding you, anything is not there. Sometimes same mom is like very aggressive, right? Very angry. Why not studying? Why not doing this? Sometimes mom is like, what you're doing? Tush. What you're doing? Tush. What you're doing? Study. You're not studying. You are scrolling Instagram, doing all of that, right? This is that condition. Now, slap is not a usual thing. That is an abnormal thing. So something abnormal is going to happen here. Yes, someone has pointed it right. Sai has pointed it right. Sai. Even I have not been slapped here. So, if you see, carboxylic acid will be formed in all the cases. Ma'am, how? Ma'am, 1 degree, 2 degree, 3 degree, all of them? Yes, all of them. Let's see what is going to happen, and you will see tautomerism, breakage of double bond, everything happening here. So we'll see one by one. First, you have primary alcohol. Primary alcohol, whether it's strong oxidizing agent or as well, it was giving you carboxylic acid. So very strong will also give you that carboxylic acid only. So in primary, there is a chill pill. You can take a chill pill here. There is no need to worry. Now there comes this turn. Ma'am, you were saying whether it's whether it's mild or it's strong or it's copper at 300 degrees Celsius, it's always going to be ketone. But ma'am, now what is happening here, ma'am? How these carboxylic acids are getting formed? Now, how do I justify this point that from this ketone, you have the formation of two acids? Can I just directly tell you, beta, from ketone, you have carboxylic acid, okay, tata, bye bye. No, we will not do that, right? Ketone is this oxidizing, this is very aggressive, right? This particular oxidizing agent is very aggressive. So it will convert this keto form to enol form by tautomerization. Tautomerization, opposite of that. 1, 2, third will be the alpha, right? So you can write it like this. This will be, this is 2 and this is, let's say, 1 hydrogen here. What will happen in tautomerism? This double bond is shifted here. You will have C, this is CH3. This double bond is shifted here. This will become CH2. This hydrogen is shifted here. This will become OH. Now tell me, we are doing opposite. Firstly, we were converting enol to keto form. Now I am converting keto form to enol form. I am doing the opposite here, right? I am doing the opposite here. This is keto to enol form I am converting. Are you able to understand what I have just done? 1, 2, 3. Double bond is shifted here. Hydrogen is shifted here. Keto to enol form. Right? Yes. Now you have the formation of double bond. Right? Now you have the formation of double bond. Right? Now what I will do, once you have the formation of double bond, same thing. Tell me what we used to do. Tell me in oxidation what we used to do. Break the double bond, attach double bond O, double bond O. Very good. So this, you break the double bond, attach double bond O, double bond O. This will be C, this is CH3, this is OH, and this 3 is so weird, right? This is C, this is CH3, this is OH already, and here you will have the attachment of double bond O, plus this will be C, where it is connected to 2 hydrogens and 1 double bond O, right? So 1, you already have this acid. 1 acid you have, but now what will happen to this thing? Now further there will be reaction, okay? Further there will be reaction. What I do with that, right? This is already formed. What I do, yaar? What should I do now? Okay, I'll just write it here, you know. I don't have space, so what I'll do, I'll just shift it here. Wait a minute, guys. I think opposite order I did, right? I'll just, because I know you are eventually going to study from these notes only, so I'm trying to make them as neat as possible, because I know in the end you are in a panic mode, you don't have time to write the notes and all, so you will get the notes and study from these notes only, right? Now see, you have this C, this is CH3. What I did, this double bond is shifted here, this is CH2, this H is shifted here, okay? So what I have here, yes, I have this OH here. Now tell me one thing. You have enol form, you will break the double bond, you will have, this is CH3, CH3, this is OH, attached double bond O here, and rest of it is, this is C, this is connected to 2 hydrogens and double bond O. This is already acid. This is not an acid. This will be converted to acid, right? How this is converted to acid, right? How this is converted to acid, you can convert it. This is HCHO. If you see this, right? HCHO, you can convert one of the hydrogen to this. Okay, wait a minute. Huh. So you can convert one of the hydrogen because then carbonic acid is not formed there, right? So because in the end you have carboxylic acid, you don't have carbonic acid here. That is the reason don't convert it into carbonic acid, directly convert it into one of the hydrogen to OH, right? So what you will have in the end, you will have CH3 COOH plus you will have HCOH. That's how you have the formation of acids here. No matter what you have, the answer will always be, ma'am, will carbon dioxide form with any strong oxidation? In this case, it is not formed, right? Okay. In this case, you will have carboxylic acid only in the end, right? Not carbonic acid, right? That is in case of oxidative ozonolysis. Now, if you have 3-degree alcohols, right? Now, same thing we have 3-degree alcohol. Tell me who will do this. This is the same process that we have. 3-degree alcohol, what will happen? Ma'am, first thing is, ma'am, you told 3-degree alcohol does not react in strong oxidizing agent, but you have a very strong oxidizing agent. What happens? They form alkenes. Now it is even simpler. Actually, 2-degree alcohol was quite tough. This was simple only. Already alkene is formed. You break the double bond here, and here you will have the attachment of CH3, CH3. This is double. Okay, this is ketone na, that is formed. Here it will be C double bond O. This is H and this is H. Now this part is directly converted to HCOH. Right, one hydrogen is converted to OH, so this is converted to carboxylic. The end point is carboxylic acid. Don't convert this to carbonic acid. That is in ozonolysis, right? That is the part of ozonolysis, right? So now this is, isn't it same as this one? Isn't it same? CH3, CO. Do I have to repeat it again? Tell me, do I have to repeat it again? It is the same thing. Firstly, enol form to conversion, then break the double bond, then you have this thing. So shall I just write it directly here? Here it will be CH3 COOH plus HCOH. So these are the products that you will have in the end, right? Okay, tell me everybody, is that clear? Is that clear? Right? Tell me, is that clear everybody? Right? Shall I move ahead? Right? No? Now let's see preparation from diols. Not one OH, there are two OHs. Right? Now we are talking about vicinal diols. Let's talk about that. What will happen? Vicinal diols. Vicinal means you have on two adjacent carbons, you have OH. These are vicinal diols. Vicinal diols are cleaved by which thing? They are cleaved by HiO4 to yield aldehyde or ketone, depending upon the number of substituents on the carbon atoms being bearing the hydroxyl group. Right, they will be cleaved to yield aldehyde or ketones depending upon the number of substituents that you have that have OH groups. Periodic acid, that is HiO4, is used here, right? This also you will see it directly only, is reduced to iodic acid. It is reduced to iodic acid, that is HiO3. CHOH oxidizes to C double bond O. This oxidizes to carboxylic acid. So let's see what is going to happen here. This is vicinal. Isn't it vicinal diol? Tell me. Isn't it vicinal? COH, COH. That is vicinal. Right, everybody? That is vicinal. Now, if I have periodic acid here, what we are going to do? What is written here? It is written vicinal diols are cleaved to yield aldehyde and ketones. Cleaved means this bond will break here. That will be converted to double bond O. This will be converted to double bond O. Understood now what I did? This bond will break, this is converted to double bond O, this is converted to double bond O, and hence you have these as your answers. Let's see more of the examples here. More examples are not given, right? So let me just ask you one more example. You have CH3, COH, this is CH3, this is CPH, this is CH3, this is OH. If you remember, pinacolone reagent is also, it looks like this, but their reagent is different, right? HiO4 is not used there. If you have HiO4 here, this bond will break and this will be converted to CH3, C double bond O. This is CH3 plus. This is C double bond O. This is CH3 and this is PH, right? That's how this is done, right? Okay. Don't spam, guys. Huh? Don't spam. Huh? This is for you only. Right, everyone? So, no, that's why it changes to aldehyde. Okay, right? Now, let's see from carboxylic acid how it is formed. Now, this particular reaction is not that important reaction. So, I'm just going to give you the reaction and move ahead, right? So, I'll tell you that which reaction is important, which is not, right? Till now, whatever we have done was important, right? Now, this reaction is not that important and it has not been asked as such, right? So, just remember, you have any calcium salt, right? This internal thing will be converted to aldehyde. Same number of carbons. One carbon, it is HCHO. This is R and C, this will be RCHO, right? Because it is 2 times of this, no? So here you have this carbonyl carbon will stay as it is. This hydrogen is here, this hydrogen is here. This carbonyl carbon will stay as it is. This R is here, this R is here, so it will give you ketone. Understood now what I did? See, this carbonyl carbon is as it is. This is multiplied, this is 2 times repeated. This carbonyl carbon as it is, hydrogen is 2 times. This carbonyl carbon as it is, R is 2 times. Okay? Acha, tell me one thing. If you have here, yes, okay, so this and this is formed here, right? Calcium salts of acid other than formic acid on heating together give ketones. Let's say if you have 2 calcium salts, you have RCO, this is R-CO. So what will happen? You will have carbonyl here, 1 R you will take from this, 1 R dash you will take from this. And that is the ketone that you will have here. Okay? When only one type of this is used, then this is double. This will be double. This will be double. Okay. When you have 2 different salts here, then 1 R group from here, 1 R dash from here. That is done. Right? Okay. Now, calcium salts of mixed acids give more than one product. Right? How come mixed acids will give more than one product? Let's see. Right? If you see this here, major product should be C double bond O. This is R, C double bond O, carbonyl. Here it is R and here it is H. But apart from this, this can also give you C double bond O, H and H. This alone can give you C double bond O, R and R. So they are saying this and this is also formed here. Right? Okay? Understood? So if you have mixed salts, so they can give you, just like in Wood's reaction, you have more than one product. In the similar case, here also it's not like only this will be formed. You can also have the formation of C double bond O, and this is R dash and this is R dash. Plus, you can also have C double bond O, this is R and this is R. And because of these so many mixed products, this method is not so useful, right? And that's why it has not also been asked so many times, right? I don't think so anytime they have asked this, right? That's why I'm not giving that much importance to this one. Now see this. you have on passing vapors of fatty acids over manganese oxide. Manganese oxide, directly you have the conversion of converted into ketone. On passing mixture of this to fatty acid with formic acid, we get a mixture of aldehyde, ketone, and formaldehyde. So a lot of product here are also formed. Right here also in the same case, C double bond O, this is R and this is R on 2 times, just same as that you have done in calcium salt, same you will do here. C double bond O, this is R here, this is again repeated here, right? Okay, right? This is also not so important, so that's why this one is important. This one is important. Rosenmund reduction, right? Let's see. These are some important things. Now again the important stuff has started, right? So acid chlorides, COCl, you have, it is reduced to, this Cl is reduced to hydrogen here. This COCl is reduced to CHO. This is in catalytic hydrogenation, but you also use a poison here, right? That poison is BaSO4, and this full thing PdBaSO4, it is poisoned by sulfur. Hydrogen is used here, that is called as Lindlar's catalyst, right? Okay, and Lindlar's catalyst also have one more use. It converts alkyne to same reagent, converts it into cis alkene. Remember, this reagent has two major uses. Alkyne to cis alkene. Achha, if you want to convert alkyne to trans alkene, you use Birch reduction, hydrocarbons, right? So remember that. Now this boiling in xylene with palladium as the catalyst supported by this. You can also use quinoline here. You can also use quinoline or CaCO3. All are poisoning this reaction, right? Okay. PD catalyst is poisoned by BaSO4, that is Lindlar's catalyst, to check the further reduction, so that the further it is, because if you remember, we know that if you have aldehyde, that will be reduced to alcohol further, which we don't want. We want to stop it to aldehyde only. That's why we are using this poison, right? Now next thing is formaldehyde cannot be obtained by this method, right? Because HCOCl is unstable at common temperature, right? Tell me, if you want to prepare formaldehyde, that is HC double bond OH. Here it should be HC double bond OH, sorry, Cl. But this thing is not stable. That is the reason formaldehyde cannot be prepared here, right? Okay. Now using alkanoyl chloride with dialkyl cadmium ketone is obtained. So R-CD you have here, this is the same kind of reaction. You have the conversion of this COCl, but this Cl is replaced by R-. If you use R-2CD, that means if you use dialkyl cadmium, to that alkyl part will replace Cl. Alkyl part of cadmium will replace Cl. Okay. Alkyl part of cadmium is going to replace the Cl here. Very good, Shiva. NH3 in sodium, that sodium in NH3, that is the Birch reduction, right? Okay. Now let's do by acylation or benzoylation of aromatic hydrocarbons. Let's talk about this. Let's talk about this, everybody. So this is benzene. Tell me, what is Friedel-Crafts reaction? You have the formation of RC double bond O. It attacks on benzene. So here CH3 C double bond O, this will be formed. It will attack on benzene. It will give you this benzene. I'll just write this here. It will give you this benzene. Benzene is as it is. C double bond O, CH3 will be attached here. Acetophenone will be formed. Then here C6H5CO positive will be tagged here. This thing will be formed, right? Benzophenone is formed. Here you have COCl2, right? In case of COCl2, you have HC, C6H6, you have COCl2. Firstly, what will happen? C double bond OCl, that will be attached here, right? This will again give you benzophenone only, right? C double bond O. Then this particular thing will replace the Cl, and again benzophenone is formed here, right? Okay. Here just remember that this is in excess. Firstly, what will happen? This benzene is going to react with COCl to give you C double bond OCl. Then it is benzene also here. Then it is going to give you benzophenone. So benzene plus benzene COCl is the same reaction. They can give you directly, they can give you C6H6 is in excess. Then you might get confused that, ma'am, I don't know what to do. Actually, these two are going to firstly form this benzene COCl. Right? Okay, everybody, let me know. Okay. Yes. Vala, I don't know if you're asking about 2026 or 27. As your mentor, I will not advise you that just 35 days before your exam you should, use a new book and then solve the questions. I will not advise you that. I would advise you do the previous year question or attempt some test series or mock test. Don't go through that. If you would have asked me the same questions 3-4 months back, or if you asked me for 2027, then obviously yes. But right now, don't play with your life, right? Okay, don't do that. Right now, just focus on revision, focus on attempting the mock test, focus on, if you want to practice something, practice previous year questions, right? Okay. Now, preparation from acid derivatives and cyanides. Let's talk about that. Dibble is very important. We'll talk about Dibble, okay? This is very important. This is very important. Let's talk about that. So what you have here, both esters and nitriles can be reduced to aldehydes by Dibble. Both esters and nitriles can be reduced to aldehyde by Dibble. Dibble is diisobutyl aluminium hydride, which is hydride donor. It does reduction. Must be carried out at low temperature. Then only it converts it into aldehyde. Hydrolysis of the intermediates give aldehyde. Right? Ester and nitriles are converted. So this is ester. So this will be converted to CHO. Right? This is cyanide. This will be converted to CHO, right? You have Dibble, hexane, low temperature, water, that's it. This you should know as it is. Esters or cyanides are converted to CHO. This bacha, you should know this as it is. Or instead of writing esters, I will write COOR. This whole group is, and this whole group is converted to CHO. That you must know for your exam point of view. Dibble is important. Which is converted to which one? That is must to know thing. Okay? Right? Yes? Tell me. Beta, if you do previous year questions in last 35 days, they are more than sufficient. Right? So you do that. If you're able to do last 5 years previous year questions, solving it in yourself in last 35 days, I will award you, right? So even when you start doing, there are so many shifts in 1 year, yeah, right? So many shifts. So you will see a lot of, it's a full packed, so many questions are there, right, in PYQs. And you will also understand the pattern, right? So definitely, if you want to practice something, practice that or attempt the mock test. That is the must. Mock test is must, right? Now, if you see this here, preparation from cyanides, this is from Grignard reagent. What is going to happen? Let's talk about that, right? Grignard reagent, remember, this is positive and this is negative, right? So this will be partially positive, this is partially negative, this is partially positive, this is partially negative. So what is going to happen? This is going to attack here and these electrons are going to jump here. So you will have RC, this R will attack here, and to this N, when these electrons are jumping here, this will have a double bond and MgX will be attached here. Now, when you do hydrolysis, this whole part is converted to this whole part is, wait a minute, this whole part is converted to double bond O, right? This whole part is converted to double bond O. Converted to double bond O. And that's how you have the formation of ketones from cyanides. And these reactions are also very important, that how cyanides are converted to ketones with the help of Grignard reagent, right? Now, if you see in the Stephen's reduction, what you have cyanides only, but here what you use, the reagent is specific here, that you use SnCl2 and HCl. This we will also do in amines. You use SnCl2HCl and that is converted to RCnNH, right? So what you have further, after further hydrolysis, this is converted to double bond O, and that's how you have the formation of RCN to RCHO, right? Because this is a very good reducing agent. It is going to break the pi bond and attach hydrogen and hydrogen here. Then this whole part is converted to double bond O, and that's how from Stephen's reduction, using SnCl to HCl along with water hydrolysis, you have the formation, this is converted to CHO. Okay, how? CH double bond NH, then this whole part is converted to O. Okay, that's how you do it, right? Okay, I'll just write this here as well. What you do here, C triple bond N is converted to, after reduction, CH, and this is NH. Then when you do hydrolysis, this is converted to C double bond OH. That's how you convert it into aldehyde, right? Okay. That's what I was telling you, Aruna. Don't worry. You are thinking about that now? Don't worry. We'll do that. We'll do that for you, right? You trust us, right? We'll do that. We'll do previous year questions with you on this platform itself, right? But you just have to spam it down in the comment section that, ma'am, PYQs we want, right? So that we can specially pick the PYQs, the pattern we know, right? We have experience, we know what is the pattern, we know what are the questions. This one question, if you do, you're able to do next 10 or 15 questions, same like that. So according to different categories of questions, we'll pick for you and you are good to go, right? Okay, so don't worry about that. Acha, now let's see some questions here. Let's see. Match list 1 with list 2. Okay, let's do this. What is this? This is CH3, CH2, this is 5. It is converted to C2H5. This is also CH3, this is CH2, 5, this is CHO. Can you see this ester group is converted to CHO? Tell me, who will tell me in the chat box? Ester group converted to CHO, it is the, which reagent has this kind of behavior? Which reagent? And let's see how many likes you have given for the session. How many likes? Just let's make it to 150 plus likes, like before 9 p.m. I'm giving you 1 hour, huh? Before that, let's make to 150 plus likes here. I want 1K like on this marathon, right? Okay, I want that. Only then I'll do PYQ sessions for you. I'll pick. So many hard work we do for you. This much so we deserve, no? Tell me, this is Dibble. Yes, ma'am, Dibble. Very good. Dibble. So A is 4, right? What about next one? This is CO. Now tell me, you have actually this we have not done till now. Let me be clear. We have not done this till now. This CO is converted to CH2. This is actually Zn. This is actually Clemmensen reduction. That is 2. We have not done it till now. We'll do this. Don't worry. We'll do this. Then you have the conversion of CHO to CHOH and CH3. Okay. MGBR. That means this is what we are doing here. This also actually will do what to do. Should I make this question in the end? Should I do this question in the end? NaBH4, all this we have not done all these things now. Chalo theek hai, I'll do this in the end, okay? When we have done this Grignard reagent as well, Clemmensen reduction as well, NaBH4 as well, right? Till now, I know that you know that it converts, this one is used for Dibble, right? Even if you know only one, A to 4, I think A to 4, still you are able to eliminate these two options. Now I'll tell you out of these two what is the correct answer in the end, okay? Firstly, let's do, that is a problem with organic chemistry. Organic chemistry has this one big problem. You know what is that problem? What is that problem? Why students find organic chemistry tough? It's actually not tough. It's not also like students are not able to use the concept. They use, if they're able to understand maths, organic chemistry is easy to understand, okay? So those who are doing maths, big questions, for them organic chemistry is definitely not tough. The problem is what? Problem is, ma'am, we understand the concepts and everything, but in one question they will ask you different reactions of some other chapters. So that's why in organic chemistry you can't skip any chapter. That is the problem. You can't skip GOC. You can't skip any chapter here. Because if you do one chapter in detail, if you don't do other chapter in detail, maybe they will ask you a question where mix of these reagents they will use. One reagent is from alcohol, other reagent is from alkyl halide, other reagent is from amine, other reagent is from this aldehyde ketone. That is the problem. In physical chemistry, you can do that because chapters are not related to each other as such. Here they are completely dependent on each other, right? That is this thing. That is a problem. That's why students find like, ma'am, what to do and what not to do, right? But the biggest benefit of that thing is everything is related. So you will find the similarities here. It's just a way how you understand things, right? So now let's see preparation of aromatic aldehyde. This is a very important reaction, that is Itard's reaction. Itard's reaction, what we do, you have toluene, you use chromyl chloride here in the presence of CH2, and this is converted to chromium complex, that is CH. Sometimes they also ask you what is the structure of this chromium complex. So it is CH. Instead of double bond O, you have OCRO HCl twice. OCRO HCl twice and whole 2, right? Then you hydrolyze it. This will be converted to double bond O, and that is your benzaldehyde that is formed here, right? Okay. Now, toluene gives the same product on reaction with chromic oxide. If you don't use chromyl chloride here, right, you don't use CrO2Cl2, and this is a red color complex, okay? This is red in color. This also you have in practical chemistry. That's why I mentioned it. What if they tell you it is reacted, toluene is reacted with a red color complex, what is formed, right? So that's why I told you. Chromic oxide also, they form the same thing in acetic anhydride. MnO at high temperature, they also form the same thing. So these two reagents, if you use, you have the same thing, that is toluene to benzaldehyde. Toluene to benzaldehyde, Right, everybody? Now, next is Gattermann-Koch reaction. This is also a very important reaction. Right? It is just like Friedel-Crafts acylation, right? If you remember. See, if you see Friedel-Crafts acylation, you know what you will think? Ma'am, if I want to convert this to this, I want this kind of electrophile. For this electrophile, I need to have this. Because what is Friedel-Crafts acylation? You need to have R C double bond O Cl and it will generate this electrophile. If I replace R with hydrogen, I need to have this electrophile. For this electrophile, I need to have this compound. And I told you that this compound is not stable. That is why Friedel-Crafts acylation is not done when you want to attach HCHO here. HC double bond O here. So what we do, if you will find the similarity here. There also we use COHCl. Here also we are doing the same thing. I don't know if you remember this or not. Here also we did the same thing. Wait a minute, where it was? I don't know where it was. Wait a minute, let me see. This was not here. This was here. I told you that if you want to have HCOCl, that is not reactive. That's why we cannot form HCHO from here. Same, because of the same factor, Friedel-Crafts reaction is not shown here. Right? Friedel-Crafts acylation will not be shown here. That's why we have to use COHCl here. We can't use that. We can use COHCl. Rest of the situation is same. Anhydrous AlCl3 and CuCl. It will form for a very short time. It will form this electrophile that will attack here, and you will have the attachment of C double bond OH here. Right? That is Gattermann-Koch. And how you can remember this? This is OH. This is CHO, CHO. That's how you can remember. Because by Gattermann, you have, 1-2 reactions you have by the name of Gattermann. Okay, right? Understood? Yes. Now, Gattermann formylation. This was Gattermann-Koch, where you are on the benzene ring, you are adding CHO. Gattermann formylation is when you have phenol, and on that phenol, you are placing CHO on the ortho or para position, right? And here, what you use, ZnCN twice HCl. Ortho and para position, you have this. This is Gattermann formylation. This is not Gattermann-Koch reaction. Okay, Gattermann-Koch is different. That is for benzene. This is different. Right? Let me see if all these we have used or not. Most of it we have used. We have not just done this reaction, right? So reaction by which benzaldehyde cannot be prepared. This also will do once we have done other reactions as well, right? Okay. Let's do the reaction part as well. Then we will do other questions because it's mixed. Okay, it's mixed. So be very frank with you. I want you guys to answer. I don't want me to answer. I want you guys to answer. Acha, see, physical properties, these are simple. This so you can do yourself also. Formaldehyde is gas. All other carbonyl compounds up to this are liquids. They never ask you this as such, but you never know if they start asking you the statement-based questions. Then do this. Right? Odor, low aldehyde gives unpleasant odor. High aldehyde and ketones have pleasant smell. That is why they are used in our perfumes and all. Right? Then solubility. Now this is a very important physical property based on which they ask you the questions. Usually physical properties, solubility and boiling point, they ask you the questions. Okay. So if you talk about C1 to C3, formaldehyde, acetaldehyde, propanoaldehyde and acetone are freely soluble in water due to polarity. right? With less carbons, if carbons are less, then this part has polarity, it is still justified. But if these carbons are more, then because of this high ring here, this polarity will not be seen. There will be steric hindrance there, right? This oxygen will not be able to be in the surrounding of next carbon, right? That is the reason, because of this high rings that you have here, right? That is why solubility will decrease here, right? So this is the cell acetone freely soluble in water due to polarity of this that can form hydrogen bond with the water molecule. So less is the number of carbon chain, more is more easy it is to form, because of less steric hindrance easily it can form hydrogen bonds. But if the carbon chain is very high, right, if I say the carbon chain is extremely large, right, then in that case it is very difficult to form hydrogen bonds, right? Okay, tell me, is that clear? Right, everybody? Next is C5 onwards, it is insoluble only. So this thing you can remember, that solubility is inversely proportional to molecular weight. If the molecular weight, the chain is increasing, then steric hindrance, someone is like this much big, okay, it has this much big chain and the polarity of carbon is this, so it will be very difficult, right? More is the big chain, it will be difficult for the CO group to form hydrogen bond, right? That is why it is inversely proportional to the molecular weight. Now let's talk about boiling point. Ma'am, what about boiling point? See, boiling point is very simple, it is directly proportional to the molecular weight, right? More is the molecular weight, more will be the boiling point, right? Let's talk about that. This though, okay, it is clear that boiling point is directly proportional to the molecular weight, right? Boiling point is an interaction that they have within themselves, right? Okay. Now, if you talk about, ma'am, this question is very much asked, that which one has more boiling point. So if you talk about hydrocarbons, they don't have any polarity, because carbon and hydrogen does not have as such difference in the electronegativity, so they don't have any polarity. In case of carbonyl compound, they have polarity of CO bond, polarity of C double bond O, this is positive, this is negative. But alcohol, it can form hydrogen bonds, and that is the reason this is the order: alcohol, then carbonyl compounds, then you have alkanes, right? Density, if you see, density of carbonyl compounds is lower than water. Carbonyl compounds will have lower density as compared to water, right? Okay, understood? Now let's see. Okay, tell me. Joker, if you're preparing for CA, then I won't advise you to see JEE lecture, na? So, yes, obviously, if you're preparing for NEET, you can definitely see this lecture. If you're preparing for board examination, then some parts of this lecture you have to skip, because something is like board and JEE has a difference. That's why some parts of this session you will have to see. It is not in your syllabus. You'll have to skip according to the board level, right? Okay. Yes, but definitely if you're a commerce student, then definitely don't watch this, right? So nucleophilic addition reaction, right? This is a very important part of aldehyde ketones and carboxylic acid, right? Okay, do you want me to give you break now? I think we can have break after half an hour or so. At least let us complete something, no? Let us complete I think thoda bahut to we can study as of now, or no? Dinner break. How many of you want break now? Only one is saying break. See, even I want break, right? But I don't want to, we can study for at least 2.5 or 3 hours, right? Then the break is applicable, right? Otherwise, so we'll take break only today, right? Okay. Tell me, how many of you want break now? Or you can wait for your dinner. Hmm. Let me see that. Let me see that in the chat box. Write it down. So let's complete. By the time you are telling me whether you want break or not, let me complete this thing, right? Nucleophilic addition reaction. Brain is braining na. Brain is braining. Brain is not stopped right now. Brain has not stopped. No. Brain is still braining, right? Still able to understand. If you think that ma'am, my brain is tired, then let me know. 1, 2, 3. So I'll make a poll here whether you want break at 9 p.m. or now. Okay. Because beta, I was to thinking to teach you for 3 hours and then give you break. Let's see. It's very close to 50%. So 58% on the boundary only we have. Right, chalo, let's do, okay? Let's do. Let's do, beta, let's do. Right, dinner break I'll give you at 9 p.m. Let's study for next 50 minutes, then have your break for 15-20 minutes, relax, and then you have your dinner. After that, 9:20 to 12 will study, right? So it's a big game that we are doing today, right? Nucleophilic addition reaction. Typical reactions of aldehyde and ketones are nucleophilic. Nucleophile is being added. Nucleophile is electron rich. Tell me on which point nucleophile will attack. Will it attack on carbon or will it attack on oxygen? Tell me. Nucleophile will attack where? Nucleophile will attack where? Nucleophile will attack on the carbon or on the oxygen. Where nucleophile will attack? Which is this is electron deficient, this is electron rich. Nucleophiles are electron rich. They attack on the electron deficient position. Yes. So nucleophile is going to attack on the all these are the same reactions. This will attack here, this will jump here. So nucleophiles are going to attack on the carbon. These double bond are going to shift here. The carbonyl carbon is electron deficient. Since pi electrons are pulled towards the electronegative oxygen atom, this part of molecule being flat is open to relatively unhindered attack. Why we told that it is flat? Because it is in a trigonal planar geometry. Ma'am, what is a trigonal planar geometry? Tell me. What is a trigonal planar geometry? A trigonal planar geometry is this kind of geometry that is in one plane, right? All of these things are in one plane. That is a trigonal planar geometry, right? Okay, understood? So unhindered attack is there. Nucleophile is going to attack here, electrons are going to jump here, right? And this is a fast step. After that you have tetrahedral intermediate. Then one of the if you see this here, in this case H positive will be attached here, right? And hence you have the addition product here. Hybridization of carbon, this is nothing but 3 sigma bonds, this is sp2. This is 4 sigma bonds, this is sp3. So hybridization is changing from sp2 to sp3. A tetrahedral alkoxide. Ma'am, why alkoxide? This OH is formed now, so that is alkoxide is formed. Sorry, this O negative is formed now. This is alkoxide is formed as the intermediate, right? This is a moderate steric hindrance. There is a moderate in the transition state. Larger group, that means if you have very big alkyl groups, will tend to resist crowding than the smaller group. Definitely, it's a very common logic. If here you have, let's say, very big groups, then definitely this attack will be difficult, right? But this is our general life also. Na? If some place is very crowded, you will find it very difficult to go. If some place is not crowded, you can easily move from there, right? Okay. Acha, mechanism of this particular reaction, let's talk about, and you will see similar kind of mechanism in other reactions as well. So this is a general mechanism. Okay, right? Okay, everybody, let's see. So what you have here, this is lone pair of electrons. This is RC double bond OR, right? Now here what you have, right? Let's say you have an acid which is going to give you H positive. This H positive will be here, and basically this bond will break and this will go here. Or you can just simply say this lone pair is going to take out H positive and these electrons will go with A. You will have A negative. Always remember one more thing about organic chemistry. If oxygen has double bond, it is neutral. If it has one more bond, it will be positive, right? So if you have attached one more hydrogen here, this oxygen will be positive, right? Now, if you see this here, which negative charge is more stable on more electronegative, positive charge is unstable on more electronegative. This is also organic chemistry, you should know these things. So this is not stable here, that is the reason carbocation is shifting here, right? Because positive charge is not stable on the more electronegative atom, so it has shifted here, and this is the carbocation that you have. Now once you have this particular carbocation, then you have here either you use this or you use this. Whatever you use, you can directly use this. You have the attachment of nucleophile here, right? Directly, if you have the attachment, directly you can also tell that attachment of nucleophile will be due to the formation of this compound, right? If you use from here, how it will give us nucleophile. If here, if I say on this position, if nucleophile attach, it will attach here. These electrons will shift here, and hence in the end what you will have, and this nucleophile with hydrogen that will be attached here. Further, A negative is going to take out H positive and these electrons are going to shift here, and that will give you the answer here. But in my opinion, this much you don't have to do. Just remember little bit of this, that how nucleophile attacks here, right? I would advise you just remember this thing. Okay, just remember this thing, right? Okay, this I told you just so that you know something is happening here, right? Okay, those who are watching it for the first time, they will definitely find this difficult, right? Otherwise, let me tell you, these mechanisms on your competitive exam point of view, I'll tell you what are important. You should know what is the sequence, right? I'm not asking you to cram the mechanisms, right? You should know that acid always. Now, why mechanisms are important? Because it's not like you should learn every step. Students, learn the mechanisms. Who is asking you to learn the mechanism? You don't need to learn that. See whether that general step is going on or not. Whenever you have an acid, acid always donates proton, and whenever you have an oxygen atom which has 3 bonds, it will always have positive charge. And always when oxygen has positive charge, it will shift its positive charge here. So you can directly remember that here nucleophile will be attached, and that's how you have the formation of this one, right? Okay, if you don't want to remember this, you want to remember it like this, then see nucleophile and hydrogen is attacking here. This nucleophile, now nucleophile is neutral. When nucleophile attacks here, it will form carbon, nucleophile and hydrogen. because it has more bonds. Now it will have positive. Whenever you have more marks than you expect, you develop a positive charge. Similarly it is with atoms. When they form more bonds than that is expected from them, they have developed a positive charge, right? Then these electrons will jump here. You will have O, this positive and negative will neutralize, and this is NH. Now again what will happen, these electrons will jump here, this will go with the conjugate base that is going to accept H positive, and that's how you have this. Okay, tell me if this reaction is getting clear, this mechanism. Beta, you don't have to learn this again. I am saying don't learn the mechanism, just see, because same steps will be done in every single mechanism. Most of the mechanisms are same only. Okay, now let's do this. Reactivity of, what we are saying is aldehyde has more reactivity than ketones. So why aldehydes are more reactive? See, this is also a very important question. This is a very important question, that why this is the reactivity order. So if you see this, alkyl is going to donate plus I effect. This is going to have plus I effect. So if you see this carbon, the whole point of attack of nucleophile is because the carbon is electron deficient. If the carbon is like, bro, I am not electron deficient, I don't need you, then nucleophile can't do anything. So in this case, this carbon is like, bro, I have electrons from these two alkyl groups, I don't need you. That's why its reactivity is low. Here carbon is like, I am so electron deficient, please, right, you can join here, right, give me electrons, and there is no alkyl group here to donate the electrons. So here that's why its reactivity is very high. Okay, right? Acha. Now this is actually based on two effects. One is inductive, other is steric. Inductive effect to I have just now told you. Steric effect is because here you have two alkyl groups, two bodyguards. This is your favorite hero, Allu Arjun, right? And these are two bodyguards, and they are like, you want to meet him, you want to meet him, you want to meet him, right? And nobody is letting you meet them. Why? Because they are bodyguards. Here you have only one bodyguard. Here you don't have any bodyguards, so you can easily meet them, right? That is steric effect, right? So that is based on inductive and steric effect. You can go through this. It is the same thing that I've just discussed, right? Okay, right, everybody? Now, if you see, aryl group stabilizes the reactant by resonance and causes a net deactivation effect of the group. Now, if you remember this, if you see this over here, if you have this benzene, this is C double bond O, this is R. This bond will shift here, this bond will shift here, and overall what it will go, this oxygen is going to take out the electrons here. That is why overall minus I effect, minus M effect. That is why these are meta-directing. Aldehyde and ketones are meta-directing. I have also told you this in GOC. Whenever you have a ring which is connected to a group that is further connected to a more electronegative atom, it always shows minus M effect. Like here it is connected to carbon which was connected to more electronegative atom by a double bond. This was initially the double bond only. It was initially like this. That's why it showed minus M effect. Okay? Tell me. Yes, everybody, do let me know in the chat box if that is clear to all of you or not. Right, everyone? Okay. Now let's see the reactivity order here, right? Reactivity order is HCHO, then you have, like HCHO means least steric hindrance is there. There is no inductive effect. Then CH3CHO, then C2H5CHO, then two alkyl groups here. Then you have two bigger alkyl groups here. It has even less reactivity. More two alkyl groups with more big chain. Then you have tertiary. This carbon is tertiary. This carbon is tertiary. So as the steric hindrance is increasing, the reactivity is decreasing here. Tell me if this particular list is clear. Do you have to learn this list? Who will tell me? Do you have to learn this? Is ma'am asking you to learn this? Is Diksha ma'am asking me to cram this? No? Why? Because it's a logic. Why you have to learn these things? Learn reagents, learn naming reaction. Why you learning these things? Right? Okay? No worries, no worries. I hope you have done good in your mock test. Right? Yes. So angle of nucleophilic addition reaction, let's talk about that. If you see this over here, guys, this is C double bond O, this is two bonds here, this is a nucleophile. What we will see, these are the orbitals, right? Maximum overlap with pi star perpendicular to C double bond O. Perpendicular to C double bond O, there is a perpendicular orbital, that is pi star anti-bonding orbital, right? Maximum overlap will be there, right, with the anti-bonding pi star orbital. Repulsion from filled pi orbitals, these filled pi orbitals will have repulsions here to attack at the obtuse angle, that is more than 180 degree, it will have a repulsion here. Nucleophilic attack, that means overall we can say nucleophilic attack of CO at 107 angle of nucleophile is the best, right? So you can see over here what is happening, right? Maximum overlap with pi star perpendicular to this, yes. So in the middle we have choose that overall 107 degree, that angle it can choose. Orbitals lean away from the node. Now what is happening here? This is the nodal plane here. So what is happening? These orbitals are not exactly at perpendicular stage. These orbitals are little bit like this. They're little bit lean away from this node that you have created here. And that is why this angle is the best angle here. Okay? Understood na what we are saying? If you have, if I talk about these filled orbitals will repel the nucleophile. You need empty pi star orbital where overlap can happen. But in reality, these anti-pi star orbitals are not at 90 degree. They are little bit lean towards like this. They are like this. They are not like this. They are like this. Okay? Not like this. They are like this. Why? Because there is a node in between. So instead of this, they are like this. Okay? Right? And that's how the nucleophile will be attacking like this, parallel to the pi star orbital, right? Now this is the very famous reaction of HCN. Let's talk about that, how cyanohydrin is formed. And this is also like too much asked in your exam. I have seen that the questions that they ask very frequently are not difficult. The ones that you find easier, actually they have asked so many times, right? Tough they don't ask as such, right? So don't worry about that, right? So this is negative, this is partially positive. So what will happen? This is RC, this is H, and what will happen? Cn negative is going to attack here, electrons are going to jump here. So this is O negative and this is Cn, right? To this O negative, what you have? Then you have the attachment of H here, that is nothing but this is cyanohydrin. Okay, got it now? This nucleophile is going to, actually this is happening in the acidic medium, I'll tell you. Yes. So what will happen? You will have the formation of Cn negative nucleophile that will attack here, electrons will jump here, you will have O negative, then H positive will be attached here, you will have cyanohydrin here, right? Okay, tell me everybody if that is clear, right? Okay, done. Yes. Acha, now let's see next part here. Next part here. If you see this, reaction takes place in the presence of mild base, which abstract H positive from HCN. Yes, mild base you will have. So that it will abstract H positive from HCN and it will have the formation of CN negative nucleophile here. Right? Okay, that you must remember that it is happening in the presence of mild base. Now, these are some of the important reactions. This is not directly asked that they will ask you what is the hydrolysis, but let's say there are mixed reactions like A to B, B to C, C to D, D to E, E to F. In those kind of reactions, you will see this, right? In those kind of reactions, you will see this. Now, if you see this, 4 hydrogens you have attached, let's say, acha, one thing you must remember here, we are using C triple bond N, right? C triple bond N. So let's say you are doing only reduction. So what will happen? 2 pi bonds will break. This will be CH2NH2 that is formed, right? Then this is cyanohydrin, the reactions of cyanohydrin. When you further add reduction, you do add hydrogen, it will be pi bonds will break, you will have CH2NH2. When you do partial hydrolysis, in that case, you will have the formation of amide. This is very important that in case of partial hydrolysis, you have amide here. But in case of complete hydrolysis, you have acid here. This is very important thing. In your previous year questions, they have asked a question where this thing was used. You know what students have done the mistake, and I have just taken the practice test of students. Just 2 days back, I have in the batch, I have taken practice test of organic chemistry. And you know what students are doing mistakes? They are doing this mistake, and those students are doing this mistake who answer things correctly always, who always know the answer of these questions. I know that they will never do any mistake, but they are doing mistakes here. So because this is not a very famous reaction. In famous reactions, students don't do mistake, they do mistake here. And you know what was asked further? Further, it was asked that you add Br2. You add Br2. See, if you add Br2 here, KOH, that is Hofmann bromamide degradation that we will study in amines, right? If you have formed this, then you add Br2. It is exactly something different is going to form. That is why these things are important for you to remember, that in partial hydrolysis, you have amide. In complete hydrolysis, you have acid from cyanide. Whether this OH is here or not, this partial hydrolysis will give you CONH2. Complete hydrolysis will give you COH, right? Then if you have Stephen's reduction, that we know CN is converted to CHO, right? In Stephen's reduction, it is converted to CHO, right? Remember these things for CN. Partial, it is amide. Complete, it is acid. Stephen reduction, it is CHO. Okay? Acha, now let's see this. If you see this, we are saying that it is actually a reversible reaction, right? Okay, addition of water. If you have water, let's talk about this. If you have water, what you have? H positive and OH negative. This OH negative will attach here, this will go here. So it will form C, this is O negative, this is OH, and H positive will be attached here, it will be this. Okay? Simple. Right? Same thing. In the same way, I'll be doing the same way. Right? Okay? Now let's talk about stability of hydrates depends upon which of the following things. That depends upon steric hindrance, presence of minus I group on the geminal diol carbon, this particular thing. Whether this hydrate will be stable or not, that depends upon the steric hindrance. If there is too much steric hindrance, then that is not going to be stable. Presence of minus I group on the geminal diol. Intramolecular hydrogen bonding is going to make it stable. Angle strain is going to make it unstable. Okay? Right? Now, let's do this question, that is K equilibrium values of HCN. Addition to the following aldehydes are in the order. Okay. Where means cyanohydrin will be more stable. Tell me. Where cyanohydrin is more stable? Anyone of you who can tell me that? If anyone of you who can tell me that where cyanohydrin is more stable? HCN added to the following compounds, right? Which is more stable here? Yes, students, do let me know in the chat box which one will be more stable here. Which one is going to be more stable here? So what we are going to see here, we are going to see this is the substituent. If you see, this is actually giving you plus M and minus I effect. Plus M is more dominating here. Here you don't have any effect. Here these are the lone pairs, but methyl is also donating the nitrogen to this nitrogen. It is also donating to this one, right? So it is also giving you plus M and this is minus I, right? Steric hindrance, if you see, so you are going to tell K equilibrium or values to HCN addition to following. Let's talk about that, right? Firstly, which one will be easy? Which one will be easy to form? Which one will easy, where it is easy to attack? If you see this carbon here, you're donating, your too much donation is there. So this carbon is not electrophilic, this carbon is not electron deficient. This carbon is electron deficient. Maximum, this carbon is electron deficient, so attack will be maximum here. In second, it will be maximum attack. Then in this and this case, you have plus M only, but here because of inductive effect, here you have 2 methyl, so more plus M is there. Here you have 1 methyl group, so less plus M is there. Because inductive, 2 inductive and 1 plus M of this nitrogen, 1 inductive and 1 plus M of this oxygen. And we know that nitrogen is more, and nitrogen has less electron negativity, so it is more easy for nitrogen, it is easy to donate the electrons. The one who is not clever, it will find it easy to donate the electrons, no? So here what will happen? It will find it easy to donate the electrons over here. Over here it will find it easy to donate the electrons, so this will be least, right? This will be least, very less speed will be there. So you can see 2, 1, 3. 2, 1, 3, right? So D is the correct answer here, right? They are just asking you speed of this reaction. They are saying that which carbon is more electron deficient. Based on that, we have answered it, right? Yes, everybody, do let me know. Tell me. No, Sabra, these, some of them are PYQs, some of them are based on PYQs. Okay? Like some of them are like little bit more extension of PYQs. Okay? Yes. Which is the most reactive towards nucleophilic addition reaction? Tell me which one will be more reactive? Most reactive. Most reactive will be one where carbon is electron deficient. Tell me, bacha, where the carbon will be maximum electron deficient. Where carbon is going to be like, I am so electron deficient, give me some nucleophile. Which carbon is going to be like that? Here you have plus I. Here you have on para position, NO2 is going to give you minus M and minus I. Now then student asked me, ma'am, where GOC is applied, ma'am? GOC, ma'am, I will skip. You will skip GOC, then these are the things that you will not be able to do without GOC. This is purely based on GOC. And if you just do GOC, even then you won't be able to do this. So that is the problem that students face with organic chemistry. You can't skip anything here. You can't. You have to do that. And right now, I will never advise you to do NCRT and all. Right now, just watch teachers' lectures. So you're doing very good that you're watching this lecture instead of studying on your own. right? Because students they don't know what is important, what is not important. They spend time and yet end up not learning the full chapter, not understanding the full chapter, right? So acha, here this is COCH3. Here it is providing to this carbon, you are providing electrons from this one. And if you see, benzene is everywhere. So most electron deficiency will be here, isn't it? Because you are subtracting the electrons from here. You are taking out the electrons. So most electron deficiency will be in the case of D. So answer is going to be D. Very good. I can see it over here in the chat box. Students are answering the questions absolutely correctly, right? Okay. Now then next question is assertion reasoning. Cyclopropanol undergo addition with HCN more easily in comparison to acetone. Cyclopropane contains 10 rings, has less crowding. Okay, tell me what we are saying here. Cyclopropanol undergoes addition with HCl quite easily. Who will tell me the answer of this one? Yes, students, who will tell me the answer for this one? You can easily answer this. You can easily answer this. Yes, everybody. Yes, students. Everybody, do let me know in the chat box. Do let me know in the chat box. Firstly, you need, if you're confused about what is cyclopropanol, so this is cyclopropanol. Okay, now tell me, cyclopropanol undergo addition with HCN more easily in comparison to acetone. Acetone is this thing, which will undergo, see, to both the things, two carbons are attached. Tell me which will undergo addition reaction more easily, where the deficiency will be more or less. Steric hindrance, in fact, plus I will not act here. Steric hindrance will tell you the answer here. Cyclopropane contains strained ring and also has less steric crowding. Yes, very good, very good, very good. I can see the answers over here. I can see the answers over here. Here, if you see, it will be over here. This has some angle. That's why steric crowding is less here, right? So that is also true. That is also true, and they are the explanation of each other as well. So answer is going to be A is the correct answer here, right? In cyclopropanol, you have less steric crowding because of this angle that is formed, right? That is why it is easy for the nucleophilic attack to happen here, right? Okay. But right now, if you're asking me for 2026, ma'am, I want to read NCERT, then I would say that is not a very wise decision that you will make, right? Right now, just focus on teachers' lectures, teachers' notes, and previous year questions. That's all you have to do now. Okay, this is what you need to do right now. You can't be reading NCERT at this point. Yes, DNF block, you can still do that, but P block exceptions you can read, but organic chemistry, I would say better to understand it from teachers' lectures, right? A and B in the following reactions are what? Tell me. A and B in the following reaction, you have HCN and you have KCN. It is going to give you CN here. This will give you RC. This is R dash. This will become CN here, and this is OH. Right? So that B or D can be the answer. This is A, right? And what is B? Where is B? This should be B, na? Then it should be written, I think it is by mistake written D. What we use here to convert this CN into CH2NH2. We don't use hydrolysis, we do reduction here. So reduction is with this one. Reduction you will do, so that means you are going to do reduction CH2NH2. So D is the correct answer, isn't it? D ma'am, D is the correct answer, ma'am. Huh? So here, if you do hydrolysis, it will be converted to acid, COH. If you do partial hydrolysis, it will be converted to amide, You want to convert it into amine, right? This is B beta, this is B. Okay, by mistake it is written D, it should be B, okay? Okay, it should be B and this is A. Okay? Yes. Understood? Yes, everybody? So answer is D is the correct answer here. Next is nucleophilic addition reaction of ROH, where we are going to form acetal, hemiacetal, ketal, hemiketal, all these things, right? And this is also a very important reaction. This is also a very important reaction. I'll categorize this in important reactions, right? Okay. Yes, students. So if you see this here, in this case, you have a ketone, right? You add here, this should be, this is not, acha, remember one thing, this R1, R2, R3 are the three different alkyl group. R3 does not mean here, R3 is not three alkyl group. It is, its name is R3. Okay, understood? So don't feel it like, ma'am, this is three alkyl group with OH. No, right? So what will happen here on this? What will this is RO negative, this is positive. It is going to attack here. These electrons are going to jump here. So it will form C, R1, R2 is already there. OR3 will be attached here as a nucleophile. And electrons are going to jump here. It will form O negative and this H positive will be attached here. This is called as a hemiketal. Whenever on the carbon you have two alkyl groups, one OH and one OR, that is hemiketal. Okay, right? Understood? Now again one more R3OH is added, then this OH will be replaced by OR3. Whenever on a compound, on a carbon, you have two alkyl, two OR groups, it is called as ketal. Okay, it is called as ketal. Now let's talk about acetal and hemiacetal. They are formed from aldehyde. Ketals are formed from ketones. The only difference is here starting point is ketone, here starting point is aldehyde. That's the only difference. Okay, so what you will have here, this is negative, this will attack here, these electrons are going to jump here, this will be OR3, this is OH, right? So hemiacetal is when you have a compound which on the carbon there is one alkyl, one OH, one OR and one hydrogen. And acetal is when you have two OR, one alkyl and one H. Okay, that is acetal. Right, everybody? That is acetal. Understood now? Acha, tell me, everybody in the chat box, tell me if I write this thing, whether this hemiacetal or ketal or what. Let us see. I want you to remember this right now on this point itself. Tell me, what is this? Is this acetal? See, whenever you have any one hydrogen, na, it is definitely acetal or hemiacetal. If on that carbon you have even one hydrogen, that is going to be either hemiacetal or acetal, right? So ketal is not possibility here. When you have one OH and one OR, then it is going to be hemi, right? Okay. Acha, tell me now one thing. If you have this thing, if you have this thing, tell me, what is this? What is this? Let me see if you can answer this or not. Let me see if you can answer this or not. What is this, everybody? Can you answer this? Let me see who answers. Sai, Rishi, Tanuja, Mohammed, sorry. Rishi, Neon, Kaustub. It is a ketal. Very good, ma'am. It's a ketal. 2 OR groups you have, 2 R groups you have, that is a ketal. Okay, that is a ketal. Okay, this is what you need to remember. Right? Okay. Now, if instead, now this is very important. If I say instead of 2 molecules of monohydric alcohol, dihydric alcohol is used and acyclic acetals are formed. What we are saying, instead of 2 molecules of monohydric alcohols, monohydric alcohols means which has only one OH. Instead of that, you are using one OH on both the sides. Then what is going to happen? This OH is there, this OH is there. What you're going to do here, if instead of 2 molecules of monohydric, dihydric alcohols are used, what will happen here? Simple thing I'll tell you. This oxygen and these 2 hydrogens are going to get eliminated, and you will have this bond with this oxygen, this bond with this oxygen. So you will have carbon OCH2, carbon OCH2, and that is how you will have this cyclic ketal here. This is cyclic ketal, and this is also a very famous reaction. This is also a very famous reaction. Okay? Yes, everybody? Now, how do you make this? The acetals and ketals are hydrolyzed with aqueous mineral acids. If acetals and ketals, let's say they are hydrolyzed, they will give the reverse reaction. It is forming this. If you add water, it will form again this and this. Okay? It is the reverse of that reaction that is going to do. Regenerate the reactants. Reverse it will happen. Right? Okay? Nucleophilic addition reaction of NaHSO3. What about NaHSO3? Carbonyl compounds form white crystalline addition product here. Ma'am, what is this white crystalline addition product? Let's talk about that. If you have this carboxylic acid, this C double bond O, here what will happen? This O is going to attack here. These electrons are going to jump here, and it will form, this carbon will be attached to OSO2H, or I would say write it instead of SO3H. Now, better you write it this way, OSO2H, because then you will know that it is bonded to oxygen, not to sulfur, right? Then Na positive will be attached here, then there will be proton transfer, and hence you will have the formation of these white crystals here. Wait a minute. What will happen? These white crystals will be formed here. This will be OH, and this will be, wait a minute, this will be OH, and this will be OSO2Na. Right? Okay? Done, everybody? Then what you have? Then you have bisulfite adduct is important compound because it gives carbonyl compound on further hydrolysis, right? This on further hydrolysis will give you carbonyl compound only, and moreover white crystals are formed here. It is visible. The reaction is given by only methyl ketone and aldehyde. This reaction is given by, this is like a distinguished test that is only given by methyl ketone. Methyl ketone means either you should have this thing or it should be an aldehyde. That means either it should be C double bond OH. Okay? Only these two things are going to give you, not given by acetophenone. It is not given by acetophenone. Right? Acetophenone is not going to give this reaction. Right? Okay? Yes, it is JEE. Acha, now let's see other things here. Due to steric hindrance, rate of reaction of the case of ketone is very slow, right? In case of ketones, why it is not showing for other ketones where it is not methyl ketone. Now methyl ketone shows, but this acetophenone will not show. This is very important. Methyl ketone will show, but acetophenone will not show, right? Acetophenone is this thing. Those who don't know what is acetophenone, it is this thing. If you see, acetophenone is also a methyl ketone. It has this, but still it will not show. Even if it has this, it will not show this reaction. This is the exception that you have. Okay. Achha, now next is, due to steric hindrance, rate of reaction in case of ketone is very slow. We are saying that due to steric hindrance, right? Rate of reaction of ketone is very slow, right? And that is why this reaction is used for the separation and purification of aldehydes. Because in case of ketones, the rate is very slow, so aldehydes can be taken out first. So that is why for the separation, we can use this test. So it has so many uses. It can be as a distinguished test, as a separation test, it can be used, right? The hydrogen sulfide, this adduct we are saying is water soluble and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkalis. It is going to give you the original compound that was there. So it is a reversible reaction. When you add water, it is going to give off back the same product, right? Okay, tell me everybody. Let's see this question now. That is, which of the following will be product of the following reaction? Which of the following will be the product of the following reaction? This is ketone, this is OH, and that is also OH there. Can you see this one thing here? Isn't it like cyclic ketal? Isn't it the same situation like cyclic ketal? If you see this over here, it is this thing. It is actually, I'll just tell you how it is done. This is actually like this. Okay, you have this. I'll just name this whole chain as R. Okay, and just to make it easy for you, this I'll name it as R. This is OH. This is OH. Now, just eliminate water from here. Eliminate water from here. Eliminate water from here, and what you will have? You will have the formation of this compound here. This is going to be O, and this is R. And what is this? R is nothing but one carbon connecting to this. R is nothing but, this is actually, I'll just write this R here. This R is, because this oxygen is connected to one carbon, here also it is connected to one carbon. So I'll write this carbon here. It is connected to one same carbon over here. That is connected to 2-methyl group. So it is the same thing that is formed. Okay, it is like cyclic ketal. Same thing we have done, just like cyclic ketal. So answer will be A is the correct answer here. Right? Okay. Now, it's just 4 minutes left. Let's do one more reaction. Right? Then I'll give you the break. Right, everybody? Achha, by the break time, let's make it to 150 plus likes. Okay, 131 you have already done. Let's make it to more. So addition of NH3 and its derivatives are there. So aldehyde and ketones react with ammonia derivatives, that is this. So what exactly happens? This is C double bond O, this is NH2Z, and this is always going to give you this compound. Wait a minute, C double bond O, this is NH2Z. It is always going to form this thing, OH2, right? That means this is C, this is 1 and 1. This is going to give you, this double bond will be as it is, right? Water will be eliminated from here, and this will be N and this is Z. This will be N and that is Z. This compound will be formed here, right? Okay. Maheen, I will take some other lecture for ring expansion. Right? I'll do some other lecture for that. Acha, tell me. Now this Z can differ. right? This Z can have different values. Same thing is there. This Z can have different values. It can be hydrogen. If it is hydrogen, see, simple compound formed is this thing. Compound formed is this thing. So if you have hydrogen, it is NH. If you have R, it is NR. If you have OH, it is NOH. If it is NH2, it is NNH2, right? So you just have to replace the Z here and form the corresponding carbonyl compound. And they also have a specific name, like this is called amine. If you ask me, ma'am, which of them is most important, all of them are important. This is important, this is important, this is important, this is all, this full table is so important. This is important, then this is important, this is important. This full table is so important. Okay, right? Okay, now remember this 2,4-DNP. 2,4-DNP is this one. This is a very famous test. 2,4-DNP, right? 2,4-DNP is generally known in the name of 2,4-dinitrophenyl hydrazine, also known as Brady's or Bosch's reagent, right? This is a very famous reagent here, right? All of them are important, but this has a specific name. It is represented by the chemical formula, that is this. It is substituted by hydrazine and red to orange solid. Red to orange solid is formed here, right? Okay. When HCHO is heated with NH3, let's say HCHO is heated with NH3, then white crystalline. Now this is like not written in your NCRT. Okay. PDF of the sessions you will get in the description box. I'll tell you where to get it. If you see this over here, right over here, you will get the PDF of the sessions. Let me just show you that. Right? Okay. If you see this over here, right, here you will click and actually, you know, it is already, thank God, right? Wait a minute. So here, if you see, here you are going to get the PDF of the session. Actually, for me, it is not showing here, but for you, it will be showing, because I am logged in from my own ID, my teacher's ID, but for teacher's ID, it will not show so, but for you, it will show a description box here as well. And that will be like, comments and doubts. You can also ask your doubts here. But session PDF, obviously, if the class is ending today at, let's say, 12 p.m. or 1 a.m., right? Then obviously, then the session PDF will be provided next day, like in the morning itself. Let's say 10 a.m., 11 a.m., it will be uploaded. Right, as soon as possible it will be uploaded. If the session is ending only at such a, you know, in almost in the morning the session is ending, then definitely it will take next day, right? Okay, yes. Now if you see this over here, when CHO is heated with NH3, then white crystalline hydrocyclic compound is formed. Now this is not mentioned in your NCRT, and it is also for JEE Advanced, I would say this is important reaction. For JEE Mains, you can skip this as well, right? So this, you have HCHO, you have ammonia. This is going to give you this hexamethylene tetraamine, that is urotropine, right? That is formed, and its structure is this, right? This is the structure, right? Okay, you can skip this. It is used in medicine or diabetes or urinary infection, right? So you can skip this for your JEE Mains, right? Achha. Next is the product formed by the reaction for an aldehyde with primary amine. The product formed by the aldehyde with the primary amine. Primary amine is what, guys? Wait a minute. This is aldehyde and this is primary amine, H2NR. So primary means you will have one alkyl group that is attached here. So here what will happen? This water will be eliminated. You will have C double bond. Instead of Z, you have R here. So you are going to have Schiff's base here. That is C is the correct answer. It is from the same table that you have. Okay, it is from this table that you have. Okay, right? That's how they can ask you the questions here. Right, everybody? Now tell me, we'll do rest of the part after the break, isn't it? Yes. Hmm? We'll do rest of the part after the break. Now you can also have your lunch, right? Or do you want to do 2-3 reactions more? Ma'am is so lalchi. So let's do this last. Okay, we'll start with we will start with RMGX. Let's do this. Okay, nahi? Chalo, why to trouble you so much? Right? Why to trouble you so much? Let's OMG, ma'am. So much we are going to do today. Right? So now this is your break time, everybody. The class is going to resume in next lunch in night. So sorry, I for dinner, beta, dinner. Right? Okay. Okay. Yes. Chalo. Now you can, relax for, because it's already 3 hours. So I'll give you break. Break time now you're going to have. And we are going to start it. A minute. Break time is there. And what is the time I should, like 9:20, I think that is enough. 9:20 p.m. Isn't it? I'll just mark it. Big mark here. 9:20 p.m. Now that much time is enough for you, na? Or are you going to make dinner yourself? That much time is enough. Thank you, everybody. 25 minutes. Beta, don't worry, I'll give you breaks in between, okay? I'll give you breaks in between. Sai, you can go reverse and pause on that tape. Pause on that, right? Okay? You can do that. Right? So I'll see you at 9:20. 15 minutes break I have given you. Right? You need break till 9:30. Beta, why so much break you need in life? I'll also give you break after that. No, I'll also give you break after that. I'll just give you, not yours, not mine. I'll give you break till 9:25. Okay, not more than that. 9:25. Okay, done. I agreed. I increased 5 minutes for you. Now have rest. Yes. Okay. Yes. Chal. Okay then. See you all in just 20 minutes. 20 minutes break is there. Have your lunch. Lunch again, I am saying, yeah. Have your dinner. I think even I need break now. Dinner time, 20 minutes I'm giving you. Go and have your dinner. Right, chalo. Okay then, guys. See you all at 9:25. Hello, yes, everybody. Where are you all? Are you guys back? Yes, students, do let me know in the chat box. Are you guys back or not? Ma'am, we will be back. But now some of you are still having your dinner. Is it? Is that the case? Hmm. Do let me know in the chat box, guys. Guys. Okay. So, hmm. So much to do today. Now, let's do this. Here, carbonyl compound from geminal halide, dihalides with PCl5. Right? What you have here, right, everybody? So you have carbonyl compound from geminal dihalide. Geminal dihalide, that means, acha, carbonyl compound form geminal dihalide. So you have carbonyl compounds, you have PCl5. What will happen? O and PCl3, right? This PCl3 with oxygen will be eliminated and you will have the formation of ClCl here. So double bond O is replaced by ClCl. Similarly, here it is replaced by F and F. Here it is replaced by F and F. Right? Okay? That's how geminal dihalides are formed. Now let's talk about Grignard reagent here. Grignard reagent is simple, guys. Here what will happen? This is negative. Negative part is going to attack on the electrode deficient carbon and the electrons will jump here and that's why this negative will attack on this Mg. So it will be H, this is C, where R will attack. This is already H and this is O negative MgX. After the hydrolysis, this will be converted to, this is H and this is R. This will be converted to 1 degree alcohols. 1 degree alcohols. Now let's talk about, after this, let's talk about this aldehyde. This is methanol. Then let's talk about aldehyde. Now this is negative, this is positive. It will attack here. Electrons are going to jump here. This will attack on this point. So you will have RC. This is O negative. This is MgX. This is positive. It will attack here. That is R dash. And here you will have H only. So after this, what will happen? After hydrolysis, this will be converted to OH and this is H and this is R dash. So that is nothing but 2 degree alcohol. That is nothing but 2 degree alcohol. Next is when you have ketone. Same process, alkyl part on carbon, electrons will jump here. It will attach MgX here. So you will have R, this is C. R double dash will be attached. Here this is R dash. This is O negative MgX. Right? Now what will happen? This will be converted to, this is R, this is C, this is R dash, this is R double dash, this is OH. Right? That is nothing but this is 3 degree alcohols from where, for which this is getting converted into. Right, everyone? Organolithium compounds, if you say, organolithium compounds also react with aldehydes and ketones in the same manner, just like Grignard reagent has reacted. Right? You have so many other organometallic compounds as well, and this is the reactivity order of those compounds. RNA has maximum, then RMGX, then R2ZN, then R2CD, then R2CuLi. This is Gilman's reagent. Okay, right, everybody? Now you can see the reactivity, the rate here. The rate, this has maximum. As you go down, the rate decreases. You can say as you go down, the rate decreases. As you go down, the rate decreases. Right? This simply means you just have to learn the priority order here. Right? Okay. Now let's see the question. Reaction between acetone and methyl magnesium chloride followed by hydrolysis will give you what? Acetone is what? That is CH3, C double bond O, CH3. And what is methyl magnesium chloride? Methyl magnesium chloride is CH3, MgCl. This is negative, this is positive. So what will happen? This negative is going to attack here, electrons will jump here. You will have C, this is O, this is MgCl, and this will be CH3. This is already CH3 and one more CH3 you have here. After this will be converted to OH. So what you will have here is the formation of A, that is tertiary alcohol here. Right? Ma'am, when is GOC? It will be soon, Chaudhary. Don't worry about it. If you show dedication here in this lectures now, that will definitely happen. Right? Okay? You just have to be consistent here, and so many things will be there for you. If you guys are not attending only the classes, then we can't do anything, right? But if you're regularly attending classes, if you accept this 9 days challenge and you actually attend every session, not only first session, usually students attend the first session, by the time third, fourth session, their energies goes down. So if you attend third, fourth session, ninth session as well with the same energy, definitely all the sessions will be there, right? But for that you have to show also that, ma'am, we are also there, ma'am. We are also accepting this, ma'am. We are also accepting these challenge, ma'am, right? Now let's see reduction of carbonyl compound. So that is done by, first is up to hydrocarbon, then there is up to alcohols. So first up to hydrocarbons, how it is done. Let's talk about clemenzin, wolf and red phosphorus. Let's talk about that. So reduction to alkanes. How reduction is done to alkanes? That will be done by clemenzin and Wolff-Kishner. Clemenzin reduction is when you have zinc amalgam in the acidic conditions, right? So here this C double bond O is converted to CH2. That is there. Okay, that is clemenzin reduction, and that is zinc amalgam in the acidic conditions. If you talk about note to be used if acid sensitive groups like OH, NH2, alkene, etc. are present in the substrate, right? If the acid sign is like this is present in the substrate, NO2 will also get reduced to this. Further, it will be converted to this. So what is going to happen? If you have acid sensitive groups in the acidic condition, what will happen? They will be acid and base group will react, right? So what will happen here? These are the bases. They will accept the proton here, right? So acid sensitive groups are going to get affected because there is acidic conditions here, right? Because of the acidic condition, for example, NH2 will be further converted to NH3 positive, OH is converted to OH2 positive, right? Then if you have NO2, that also will be converted to NH3 and that then to NH3 positive. These are acid sensitive groups, right? Okay, then what you have? Reduction by Wolff-Kishner reduction. Wolff-Kishner reduction is what? In this case, again, it is the same reaction, right? And this process is called deoxygenation because oxygen is removed. It is the same reaction. The conditions are different. The reagents are different. You use hydrazine in the basic conditions here. So here base sensitive groups will be changed to be used in presence of base sensitive groups like X, right? Okay. So here that is the thing, and here it is Wolff-Kishner reduction. It is in the presence of base, right? Okay, understood? Now with red phosphorus and HI, what you are going to do, again this is also reducing. It is also going to convert carbonyl to CH2 only, but how it is going to do, let's see. If you have an acid, this will directly convert this whole group to CH3. If you have acyl, this will also do the same thing. If you have ester, it will also do the same thing. If you have ketone, it will also do the same thing. So all these groups that you have, they will be converted to CH3. All these, whether it's acid or acyl, chloride or ester or ketone, all these groups are directly converted to the group, that is CH3, right? Then let's talk about other reducing agents that are used here, right everybody? That is H2, platinum and nickel as the catalyst, NaBH4, and this is very important, right? Very important. Then sodium ethanol, this is also important. Aldehyde primary, ketone gives secondary. Let's talk about this. Okay. So all these reducing agents whatsoever you have, now they are not going to convert this into hydrocarbon. They only have the capability of converting it into alcohols, right? So any of the reducing agents you use, they will convert into corresponding alcohol. Like aldehyde will give primary alcohol, ketone will give secondary alcohol, right? Okay. Now if you have this here, let's talk about cinnamon aldehyde. You have LiAlH4. Now if you use this here, if you see, will double bond be reduced or not, that we have to see, right? So let's see this thing. If you have, wait a minute, C double bond H, CHO, yes. So if you see this thing here, if LiLH4 is present in the acidic condition in the cinnamon aldehyde, then this is a very important reaction, because this is like a different reaction apart from others, right? In the usual case, what you will see, CHO is converted to CH2OH, right? And double bond is not affected here, right? Why? Because we are not using acidic condition. But if you use acidic condition, this double bond also will be affected, and that also will be reduced here, right? Okay. Yes, everybody. Thank you, Shokab. Thank you. Right? Done, everybody. So what we are doing here, LiLH4 reduces double bond in cinnamon system. Otherwise, it does not reduce C double bond, right? It only reduces double bond in the cinnamon systems. So if you see this over here, LiAlH4 you have. In this case, what you will see, this is not the cinnamon system, that is the cinnamon aldehyde. Only in these system it is going to reduce. This is not the cinnamon system, only in the case of cinnamon aldehyde it is going to reduce the double bond. That is a very important point. Again and again I am saying, if there is a cinnamon system, that is benzene, CH2 double bond CH, then CHO, only in that system it is going to reduce the double bond. Otherwise LiAlH4 will do nothing to this double bond here. Here also it is doing nothing to this double bond. This double bond is as it is here, right? This double bond is as it is here, right? Okay, that you must know. Then let's see sodium and ethanol. What is going to happen here? Reduction of aldehyde and ketone by sodium and ethanol. It is electron transfer reduction. Sodium is source of electron, ethanol is source of proton. That is cool. But what it is going to do, esters give aldehyde, aldehyde give ketone. So what is important, esters also are reduced in this sodium and ethanol. Esters are reduced to aldehyde, aldehyde are reduced to alcohol directly, right? Okay. Reduction of benzaldehyde by sodium ethanol. If you see benzaldehyde, how it is reduced, let's talk about that. Benzaldehyde undergo reduction via coupling reaction and product is vicinal. So what you have this here, this is benzaldehyde, two benzaldehydes are there. This is, if you remember, this is opposite of one of the reaction that we have discussed, that here you have COH, COH, right? I told you, break this bond, convert this to double bond, O double bond. It is opposite of that. Here what will happen here, this will be converted to OH, this will be converted to OH, and they will form a bond here, right? This will happen in the case of sodium ethanol, and this is also an important reaction of benzaldehyde, right everybody? Okay, tell me. Then what about magnesium amalgam? Ketones undergo reduction by coupling reaction and product is vicinal cis diol. If you talk about magnesium amalgam, again ketones, what they will do, they will make a bond here. This will be converted to OH, this is converted to OH, and this happens in the case of magnesium amalgam, and they form vis. Vis means on the different adjacent carbon you have OH, cis means on the same side, and diol, right? Okay. When this reaction is carried out in the presence of Mg amalgam but in TiCl4, if you use this, here you have not used TiCl, titanium chloride is not used here. Here you have used titanium chloride, and that is the reason in this case trans diol is formed. Okay. When you use TiCl4, trans is formed. Just remember T for Ti and T for trans. Okay, when you don't use TiCl4, then cis is formed. Right, everybody? Tell me. Okay. Then there is oxidation of aldehydes. Let's talk about oxidation of aldehydes. Yes, students? Now, if you see this over here, how do we do oxidation of this aldehyde? Let's see. Aldehydes are easily oxidized to carboxylic acid on treatment with common oxidizing agents like HN or this and this, right? So directly, because after aldehydes, the next step is carboxylic. See, alkane to alcohol, alcohol to aldehyde or ketone, aldehyde and ketone to carboxylic, right? So that's why it is there. Now we will talk about some very important distinguished tests, Tollens, Fehling, Benedict, all these things we are going to talk about. So let's do that. That is very, very important, right? That is very, 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 very important. All these reactions, Tollens, be it Fehling, be it Benedict, right? Okay, yes. So ketones are generally oxidized under vigorous conditions like strong oxidizing. This, you don't have to go through this. This is just the theory part of that. Okay, let's understand that. First thing is, when you have KMNO4, what happens, right? For this, we will learn Popoff's rule. When you have KMNO4 and you heat it, what will happen? In this case, you have a ketone. You will break the bond, right? Here you will have the attachment of, on this you will have, with the same number of carbon you will form an acid here, with the same number of carbon you will form an acid here. What I am saying, you have any ketone, you have R, C double bond O R, you will form two acids here, you will break this bond, you will form R, C double bond O. Let's say this is R dash, you will form R. If this is R, na, then with the R number of carbon, you can't add one extra carbon here. So what I'll do na, I'll just write here CH3, C2H5. Okay. So let's say you break the carbon. Let's say this bond you will break. With the same number of carbon, you will have a carboxylic acid. Here two carbon are there. So you will have CH3COH. But the question is, ma'am, who will tell us that this bond I will break or this bond I will break? That is the main, that is why Popoff's rule was made, that which CC bond to break. So it says that the C double bond of unsymmetrical ketone will always stay at side where smaller alkyl group is present. A teacher, right? The student who is always like able to understand everything. A teacher knows that he is able to understand everything, so she or he will not put that much concentration on that student. Why? Because we know that if they have doubt, they will ask. But there is one student who is not able to understand anything. We try to focus on that student, right? So that we can also make that student who is not able to understand everything. Isn't it? Isn't it? So here the focus is more on that student which has less carbons. So focus is it. If you see, let's say right now I am saying that I don't know which bond to break. right? Firstly, tell me, this is carbonyl, it has one carbon, it has two carbon. So carbonyl will stay with that carbon which has less number of carbon. So that is why this particular bond will break. And here you will have ethanol, here also you will have ethanol. Tell me guys if that is clear to all of you or not. Tell me guys if that is clear to all of you or not, right? Isn't it? Understood? Tell me. Understood? Galaxy, you can watch on the live sessions only. I have taken 3-hour session of GOC as well. You can watch that. If you just want a quick revision, then you can watch a 1-hour revision as well. Okay? Yes. Done, everybody? So, next is, now we will talk about strong oxidizing agent, mild oxidizing agent, what they all do, right? So let's talk about these tests here. That is Tollens test. First is the Tollens test. Tollens test is shown by all aldehyde, not ketones, all aldehyde. I shows this test. Hemiacetals will show. Alpha hydroxyketone, formic acid. Usually students now they just know aldehyde shows Tollens test. Who will learn all of this? What if they give you this in the exam? Hemiacetals they show. Formic acid it shows. Alpha hydroxyketone. Alpha hydroxyketone means this is ketone. On the alpha position you have hydroxy. This is alpha hydroxyketone, right? They show positive Tollens test. And terminal alkynes, if you talk about terminal alkynes, shows positive Tollens test, but no silver mirror is formed, right? And those who are confused, ma'am, what do you mean by that? We have done it, and where we have done it in the alkynes part of hydrocarbons, right? Okay. Now, what is this test? You have AgNO3, it forms this silver ammonium solution, that is Tollens reagent, and it converts CHO to COO negative, right? Majorly, they don't ask you this reaction as such. Let me tell you that these reactions are not asked. Mostly they ask you which of the following shows Tollens test. Mostly these kind of questions is what they ask, right? That's why this point is most important for you, right? Okay. Then you have Fehling's test. Now in this case, what is Fehling A solution? That is CuSO4. Fehling B solution is alkaline solution of sodium potassium tartrate. That is also called as Rochelle salt, right? Okay. Fehling solution and A and B are mixed together, right? But you know, Fehling solution you can't prepare it before, because it will not be reactive after that, so you have to prepare it on the spot, right? And another thing is that it is only shown by aliphatic compounds, only by, not aliphatic compounds, only by aliphatic aldehydes will show this reaction. Only aliphatic aldehydes are going to show this reaction. Okay, right, everybody? Only aliphatic aldehydes are going to show this particular reaction, right, everyone? So let's see this over here. In Fehling A solution, you have, this is Rochelle salts, that is sodium, potassium, and this whole is tartric acid, no? If you put here H and H, that is tartric acid. So it is sodium, potassium tartrate. That gives you deep blue complex. But when you react it with aldehyde, and that to aliphatic aldehydes, that gets converted to brown red precipitate. That means there is some aliphatic aldehyde present. Then there is Benedict solution. What is Benedict solution? In this case, instead of tartrate, you use citrate. That is the only difference. Everything else is same, right? So instead of tartrate, you use sodium citrate. Now, ma'am, why it is used? If we have Fehling solution, then why Benedict solution was made? Because Benedict solution, you can prepare it before, right? It can stay for a longer time. That is why for commercial, like for lab purposes, it was made, right? Otherwise, everything is same. Initially, it will be of blue color and then it will get transferred to reddish precipitates, right? And also, it is also shown by only aliphatic aldehydes. Uh, it oxidizes aliphatic aldehydes, hemiacetal and alpha hydroxy ketone and formic acid, right? Aromatic aldehydes do not reduce, are not, this is very important point, that aromatic aldehydes are not reduced by the Tollens test, right everybody? Okay, understood? I think that is again repeated, is it? Yes, I think this is by mistake, it is repeated. Huh. Okay, so then what we have, this is HgCl2. So whenever you have aldehydes, right, what they are going to do, whenever you have aldehydes with Hg2Cl2, they are going to give black precipitates of Hg if there is aldehyde present here. That is the reaction of HgCl2, right? Okay, and sorry, Hg2Cl2. Okay. When you have HgCl2 reacts with this, it will form Hg2Cl2. Then further Hg2Cl2 reacts with aldehyde, it will give you black precipitate. Just remember, HgCl2, if there is aldehyde present, it will give black precipitates. That's it. Okay, remember that thing. HgCl2, it will give black precipitates if there is aldehyde present. Then there is Schiff's reagent. Schiff's reagent is dilute solution of para-rosa aniline. Wait a minute. Right, hydrochloride or magenta dye. Right, what is exactly happening here? So this is Schiff's reagent. You don't have to remember the structures and all. Just remember what the test, right? So if I say colorless to negative test, it is giving, right? So if it is turning colorless, then we will say aldehyde is absent. If it is turning magenta, then we will say aldehyde is present. Just remember this thing. If it is giving a magenta color, right? This is the magenta color, right? Then we say that aldehyde is present when it reacts with Schiff's base and it gives you magenta color, right? Okay. Pink color is discharged by passing SO2. Then how it is discharged, colorless solution is called Schiff's reagent. Aldehyde react with this reagent to restore the pink color that you have, right? Schiff's base is already pink color, right? You pass SO2 gas, you decolorize that Schiff's base. Then if you put a drop of aldehyde and if it the color restores, that means this compound that you have used, right, that is aldehyde. Okay, right everybody? What we are saying, I'm saying if you have Schiff's base that is already pink color, right, you pass SO2 gas, it turns colorless, right? Then again, if it is colorless only after adding the compound, then it is not a test of aldehyde. But what happens that when you add aldehyde here, what will happen if again the color appears, magenta colors appears? That means we can say aldehyde is present here, right? Okay. Achha, let's do some questions here. First question here is, crutonaldehyde, that is this, can be easily oxidized to crutonic acid by using what? So you don't want to react this with you don't want to disturb the double bond here, right? Okay. And you have HNO3, you have acidic K2Cr2O7, which is going to react with this double bond O, right? And then you have this CHO, right? So what you're going to do here is you're going to use the Tollens reagent here. Tollens reagent does not affect C double bond C group. Only aldehyde is oxidized to COH. Nowhere in the Tollens reagent we have seen, even Fehling you can use. It's not like only Tollens you can use Fehling as well here. Because these KMNO4, K2CR2O7, they are not specific reagents. But Tollens, Fehling, Benedict, they are specific. So they all can do this work. But in the option, there is only Tollens, so we'll use only Tollens. Acha, now next question is from the compounds given below, the number of compounds which give positive Fehling test. Now tell me, which will give positive Fehling test? Positive Fehling test is given by which of the following, guys? Tell me. Positive Fehling test is given by which of the following? Who will tell me that? Who will tell me that? Yes. And let's make the likes to 200 plus likes. Okay, let's have the target. Chalo, tell me. If you see, it is only given by aliphatic aldehydes. So this benzaldehyde is ruled out. Acetophenone is ruled out because acetophenone is also like this, na? C double bond O CH3, right? That is also ruled out. Benzaldehyde is this thing. That is also ruled out. Methanol you can use. This is also benzaldehyde. It is ruled out. This is cyclohexane carbaldehyde. Now this is not aromatic. This is alicyclic. So this can be there. Acetone can be there. Right? Acetaldehyde. Acha, acetone also, why it will give you? Array, acetone also will not give you. Ketone to never give this, no? Right? Acetaldehyde it will give you because it is aldehyde, it is non-aromatic. Methanol can give you, yes. So 1, 2, 3. So answer is going to be 3 is the correct answer here. Right, everybody? Okay. No, why 5? Array, why you, acetophenone will not give, these will not give, and this will also not give. So you're left with acetaldehyde, methanol, and cyclohexane carbaldehyde. So answer is 3 is the correct answer. Okay. Yes, everybody. Acha. 1, 2 questions now we have not done over here. So let me just go back. Let me just go back. If you remember, this was the question that I told you that we will do soon, right? So here, if now you can see this over here, now we have done all these, Aldol we have not done now here. Aldol we have not done. Shall go back to that again. Chalo, koi baat nahi. You will do it in your homework. PPT will be provided to you. You will do it in your homework. Now let's talk about oxidation of ketones. Let's talk about oxidation of ketones. Tell me, how do you answer oxidation of ketones? Right, let's talk about. Ketones are not oxidized by Tollens or Fehling or Benedict. Then what you will do? Then we will do this. Oxidation under vigorous conditions, it means strong oxidizing agents at elevated temperature is required. Oxidation involves CC bond cleavage to form a mixture of carboxylic acids having less number of carbons atom than the parent ketone. So let's see how it is done. Right? Let's see how this is done. So you have this oxidation. Now, if you remember, I told you about the Popoff's rule. This is the same Popoff's rule, right? So what you will do, you will break the C1, you will break bond here. The bond that you will break, this will have more carbons, this will have less carbon. Only then you will break the bond. This will form the carboxylic acid with R plus 1 carbon, that is RCOH. This will form R plus 2 carbon, that is R dash CS2COH. Right? Okay, this is by Popoff's rule, will understand. Right, okay, and let me give you one example here of this. Okay, let me give you that example. What will be formed? Okay, how Popoff's rule will be used. This is a general reaction, but you must know how it is applied in the questions, right? Okay, so I'll just write it there. Achha, now see what will happen. Here you have CH3, right? And this is CH3 here. Now see, tell me, this is ketone and where you have less number of carbons. Less number of carbons are here. That means the bond will break like this. CO will go to that carbon, that chain which has less number of carbons, right? So it will behave like this. This will be CH3, this will be CH2, right? Then it is going to be acha. Two carbons, here you have two carbons, here you have two carbons, so both of them will form ethanol. So two ethanols will be formed here, right? Okay. Yes, everybody. Then there is Beers-Villager oxidation. What is that? Let's talk about that. Yes, everybody. Let me know. Let's talk about this. What is Beers-Villager oxidation? The oxidative cleavage of carbon bond of adjacent to carbonyl, which converts ketone to ester, cyclic ketones to lactones, right? And this is called, this is oxy-insertion. Let's see what exactly we do here. Don't remember the mechanisms and all, directly we'll see what we are going to do here. You have this ketone. In the Beers-Villager, what will happen? This will be cleaved and here one oxygen you will add, right? This CO you have now, one oxygen you will add. I'll just give you some more examples here. If you see this over here, wait a minute, right? Oxidative cleavage of CC bond adjacent to carbonyl. Adjacent to carbonyl, one bond will break and you will have the insertion of oxygen here, right? Carbonyl which converts ketone to esters and cyclic ketones to lactones. So, okay. The specificity of the reaction depends on the relative migratory ability of the substituent attached to the carbonyl group. So this is the migratory aptitude. Happy me 3 to 1. This always I tell students how to remember. Happy me, right? 3, 2, 1. This migratory aptitude you are going to use in so many different ways, right? Okay. Now let's see the rearrangement. Okay, a reaction is carried out in the per acids. Per acid means what? Per acid means C double bond O. This kind of bond should be there. Whenever you have per acids, not acids, per acid, when there is one extra oxygen, O double bond O, per oxy bond is there, then it is going to give you, for example, you have this thing. Okay, now what it will do, because hydrogen has, it is happy me, right? Methyl is after hydrogen, so more priority is given to hydrogen, right? So cleavage will be here like this. So that is why oxygen is going to get attached here, right? That is how you have the formation of acid. If you talk about this compound here, this is 3, 2, 1. 3 degree, then 2 degree, then 1 degree. But here what you have, this is 1 degree and 1 degree, both the cases are there, right? So we will talk here about this, like if you see this is CH3, this is CH3, CH2, phenyl and all we can't tell, but we can tell this on the basis of carbon atoms, right? So if you see again Popoff's rule we will apply, here, simple. This particular atom, this is carbonyl, this has only one carbon, this has two carbon. So cleavage will be of this particular bond, right? Similarly here you have phenyl and you have methyl. Now if you see what is going to be the cleavage, obviously happy me, you can understand it from there that cleavage will be from phenyl part, right? uh, because it is happy me, right? You can understand it from here, it is from the phenyl part, or you can also understand it from here. This is one carbon and this is so many carbons, so definitely cleavage will be from this side. Okay, cleavage will be from this side, and wherever the cleavage is taking place, there you will attach one more oxygen here, right? Okay, tell me, welcome to the channel, welcome to the channel, students. Acha. Now reaction due to alpha hydrogens, let's talk about the reactions that are due to alpha hydrogens. uh, Today morning only I did, today or tomorrow? Today morning I did chemical kinetics CYQs. You can go and watch that. Okay? Yes. Now if you see reactions due to alpha hydrogens of aldehyde ketones are acidic. Why they are acidic? Because of this high polarity, these alpha carbons are acidic. That's why these hydrogens are very acidic. They can also easily leave from here. Now, because of these alpha hydrogen, there are so many reactions that they are going to give you, right? So this is the alpha carbon and this is the alpha hydrogen. This is acidic because of strong electron withdrawing effect of carbonyl group, right? Resonance stabilization, even if when hydrogen is being replaced, it is being eliminated, right? You have carbon negative, and you can see that here you have, in this particular case, you have a lot of resonance that is going on here. This bond is shifted here, this bond is shifted here, so easily resonance is taking place. Negative single bond, double bond. Resonance requirement is accepted, na? Requirement is accepted here. So that means first thing is the conjugate base that you have, that is quite stable, right? The thing is that this alpha hydrogen is very acidic because of this CO bond has very good electron withdrawing group, right? And that is the reason it gives you so many different reactions. First is tautomerism, D exchange, alpha halonation, then haloform, then alpha alkylation, all these reactions because of the acidic nature of alpha hydrogen. Okay, yes everybody? Now let's see how it is going to do that. Now let us see how it is going to do that. Oxidation of methyl ketone, right? That is haloform reaction, one of the most important reactions here. What they ask you in haloform reaction is which of the following will give iodoform test. This is a very frequent question that is asked, right? But we'll see that what exactly is this test. Aldehyde ketones having at least one methyl group give this test. But I will say, remember that CH3, C double bond O, this will give aldehyde or ketone. If you have this, it will give the test. Or you have CH3, this is COH and this is H. These two situations when you have, they are going to give the test, right? These two situations are going to give the test, right? Aldehyde and ketones having at least one methyl group linked to the carbonyl carbon atom gives this test. Methyl ketones react rapidly with this in the presence of alkali to give haloform acid. Let's see what is the reagent exactly. So if you see, just remember that the reagent is NaOH, or you can say NaOH in presence of X2, or you can say NaOH. That is the reagent. And what is haloform? This is haloform. This thing is called as haloform. This is called as haloform. And CHI3, if you have, that is of yellow color. That is the most famous test. That is iodoform test, right? Okay, that is the most famous test. What happens here? R C double bond O CH3. What will happen? This bond will break. This will become C double bond O ONA, and here X will be attached. That will become CHX3, right? Okay, it is a big mechanism that you have over here, right? So here if you have Br2, because this is methyl ketone, so that is why it will give this test, right? You just have to see which of the following will give this test. If you have C double bond O CH3, it is going to give the test, because that is important for you in the end. Yes, CHX3 is formed, that is there, right? Just remember which of the following gives this test. The oxidation does not affect a carbon. This is very important, that it will not affect carbon-carbon double bond if present in the molecule. The reaction, these notes that are written here, they are useful for your competitive exams, right? The reaction is used for detection of CH3CO group, or this, as I have already written there, these groups will be detected here, right? Then next is tautomerism. We have discussed in detail. I've already told you how to solve it. You have this form. This will be 1, 2, and 3, right? This hydrogen will be shifted here. You will have OH. This double bond is shifted here. You will have double bond O. Keto-enol tautomerism, right? Why this is so? Because this is the alpha carbon, and this hydrogen is very acidic. Tautomerism also takes place because of the acidic nature of alpha hydrogen. This is what we want to tell here. Otherwise, tautomerism is there in GOC. Tautomers are rapidly converted. Tautomeric equilibria are catalyzed by traces of acid or bases. Has been covered in isomerism, that we have already done. Equilibrium between tautomerism often strongly favors one of the isomers. Acetone, for example, mostly it prefers keto form, but sometimes enol form is also preferred. Most of the cases it will prefer keto form, right? Okay. Yes, students. Ionic equilibrium. Okay, I'll do that. Okay, Lokesh. So if you see racemization and de-exchange, if you see this here, deuterium, how if you add add heavy water here, these hydrogens are replaced by deuterium. Why? Because they are acidic in nature. That's why they are exchanged, right? Okay. Alpha carbon is chiral, undergo racemization. If you have alpha carbon, if it is chiral, then this will undergo racemization. That means you can add it here, or it will be on the opposite side. D will be here, or D can be here, right? They are enantiomers of each other, right? If you see this, if the alpha carbon is chiral, they will form, these things are important. When a good level question they ask you these things. When alpha carbon is chiral, then when you exchange deuterium, it is going to form enantiomers there, right? Okay. Now this is, oh my god, such an important reaction, aldol condensation. Mark it, very, 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 very important. Right, everybody? Let's do aldol condensation. Let's do aldol condensation. Right, everybody? Do let me know in the chat box. Are you all ready for aldol condensation? I need full attention over here. Let me know. Aldol condensation requires your full attention. right? Okay. So tell me if you're ready for that. Aldol, cross aldol, Cannizzaro, cross Cannizzaro, all these reactions, right? Okay. Let's see this. Yes, ma'am. Only one student is ready. What about others? Are you guys sleeping? Tell me, tell me, tell me. I want full attentiveness here. Aldol, like very high chances, very high chances, right, of asking this in the exam. Very high chances, right? So I'll give you like a way to like answer the questions here. Aldol, cross aldol, intramolecular aldol, Cannizzaro, cross Cannizzaro, like all these reactions, right? Okay, they fall into the same category only. So first thing is, in aldol condensation, there should be at least one alpha hydrogen that should be present, and it uses dilute alkali as the catalyst, right? Now we will see how it is done, why it is called as aldol condensation, how it is formed. So I'll show you this with the help of an example. You have this. Now this is self-aldol. How do you solve this? Let me tell you. Simple way, how do you write it? If it is self-aldol, CH3, in one molecule, open the carbonyl. In one molecule, open the carbonyl part. In the other molecule, open the alpha carbon part. Here, carbonyl part I will not open, because the chances of doing mistakes, that's how we are going to reduce, right? In one, open the carbonyl part. In one, open the alpha carbon part, right? Same thing we will apply everywhere. Now you are going to attach alpha carbon with the carbonyl carbon, and you're going to write it CH3. Carbonyl carbon is converted to OH. This hydrogen will be shifted here. This will become CH2. This will become CH2 because that is alpha carbon, and this is CH2. This is aldol. See how easily we have done this. Aldol. Aldehyde and alcohol. Aldol. Okay? Understood how we made aldol? When the session will end, that to I am also waiting, right? Don't worry, yaar. A session will end when the chapter will end, right? Do you want me to do hodgepodge? No, right? So wait for some time. Wait a minute. This will be one hydrogen only. Wait a minute. That is 1, 2, 3, 4. CH2, wait a minute. CH3 you have here. Achha, that is shifted there. Na? This hydrogen is shifted there. Okay, now if you further heat it as well, if let's say you are heating it also, then condensation will take place from the alpha and beta position. From alpha position, hydrogen will go. From the beta position, OH will go, right? So you will have CH3, C double bond. This is H, this is CH, this is CH. This is called as alpha beta unsaturated, because on the alpha and beta position you have double bond, unsaturated aldehyde. So when you don't heat it, then you have aldol. When you heat it, you have alpha beta unsaturated compound, right? Okay. Now same thing I will apply here. Whether BSOH twice is given, if there is alpha hydrogen, that means aldol is going to happen. CH3, C double bond, I'll open this. This is CH3. Way of writing I am changing, okay? This alpha now I will write COCH3. Alpha I will open here. This is alpha carbon. What I told you, this will be connected. These two things will connect. So how do you write it? CH3, this is C. Double bond O is converted to OH. This is CH3. It is connected to this alpha carbon, that is this. Then CO, CH3. That is This is not aldol, this is ketol, right? But it is written as aldol only, but to be specific, this is ketol. Now from the alpha and beta position, this will be eliminated and you will have the formation of right, this thing, right? Okay, that is formed here. Let me know if that is clear. Yes, students, do let me know if that is clear to all of you or not. Right? Okay. Yes. Okay. Cross aldol, है ना? Let's talk about theory part and all that we'll discuss. But right, we'll need to think about the application part here. Theory part is same thing when you have two different compounds, right, which have alpha carbons, which has alpha hydrogen. So let's talk about when you have CH3CHO and CH3CH2CHO, ethanol and propanol, then what is going to happen, right? CH3CHO plus CH3CH2CHO. Four products it will form, and let's write those four products, what it is going to form, right? Okay, let's see what are these four products that it is going to form. So if you see this over here, this is if you see this, this is nothing but this is CH3. First product is self aldol of CH3CHO. Okay, so CH3 C double bond O H, with itself only it will make the product. So this will be written in alpha. This is CHO. You will just attach carbonyl alpha here, and you will have the formation of CH3 COH. Carbonyl is getting converted to OH. This is CH, alpha is connected here, and you have this. After the condensation, you will have CH3 CH double bond CH CH. That is, we have done before as well. Second is when the two propanals are reacting with each other. Okay? When two propanals are reacting with each other. So you write firstly the carbonyl carbon like this. Then write the alpha carbon. Alpha carbon is what? This is CHO. Next to this you have alpha carbon, so it will be CH. This is a hydrogen. This is CH3. This is the alpha carbon that you have. Understood now why I have written it that as alpha? You connect carbonyl carbon of one compound with alpha carbon of other. So this carbonyl carbon is connected to alpha carbon. So how do you write the answer? Answer is CH3CH2. This is converted to OH. This is converted to OH. This is H. It is connected to this. This is CH. It also has this CH3 here. It also has this CH2. After this, what you do, I'll just do it here only. This will be replaced. This will be eliminated, and you will have the formation of double bond here, right? And I'm saying that you heat it as well. Okay. Now third is cross aldol. In cross aldol, two are self aldol, and there are some reaction where 7-8 products are also formed because of so many different alpha carbons, right? Third is you have this. I'll use the carbonyl of this one. I'll use the alpha of this one. This is alpha. So I'll use this as CHO, CHO. This is CH. This is hydrogen. This is CH3. Just connect this with this one, and what you will have? You will have CH3C. Wait a minute. You will have CH3. This is C. This is converted to OH. This is H. This is C. This is H. So I'll just write CH, CH3, CHO. Okay? That you will write. Then you will eliminate here OH and H here. That will be double bond, and this is C. Okay, understood? Now I'll do the reverse here, opposite. I'll use alpha of this one and carbonyl of this one. So now here I'll do CH3, CH2, C double bond OH, and this is CHO, C H2H. These two are connected. So what you have, CH3, CH2, C, this is converted to OH, this is H, this is CH2, CHO. Then all you have to do is take out this hydrogen water from here. This will become CH, this will be double bond. Understood? Tell me. Yes. There is no major product. It's a mixture of products. Okay? Mixture of products are formed. Mixed products are formed in cross aldol. Right? Ketones can be used as one component in the cross aldol component. So now this is one thing. In this case, this one has no alpha hydrogen. This has alpha hydrogen. This has no alpha hydrogen. This has alpha hydrogen. So what you will do? You will write it this way. How I will write it? I will write it in the form of COH. This I will write it in the form of C double bond OH. This I will write in the form of alpha hydrogen. I told you always connect the carbonyl to the alpha hydrogen. Carbonyl to alpha hydrogen. So this is benzene. It is C. This is converted to OH. This is H. It is connected to CHO, CO, and this is again benzene. Isn't it the same thing? After this, eliminate. After this, eliminate this and this hydrogen from here. You will have the double bond. Same thing I am doing again and again. Isn't it? Tell me. Aren't we doing the same thing, guys, again and again? We are doing the same thing here. Right? Okay. Yes. Tell me, students, everybody in the chat box. Now we will see intra-aldol condensation. Within the molecule, how this happens. And this one is also very important. If they ask sometimes very good question and students tend to get confused in the exam. Intra. See, for intra, also I'll tell you a simple way of answering. I'll just copy paste this and I'll just erase this and I'll tell you how to answer. See, simple way is, if you see this here, just see what I told you. You have to select two things here. If there's more than enough for J, don't worry, right? So if it would not have been enough for J, this chapter I would complete in just 2-3 hours. It's 4 hours and we are still doing it. That means something we are doing here, right? Okay. So see this thing. One, you will use carbonyl. I'll use this, the carbonyl, and this I'll use alpha. Now the question is, should I use this alpha or should I use this alpha? Tell me, everybody. Very beautiful thing here you will learn, that if I connect this to this, I will have 1, 2, 3, 4, 5, 6 carbons. If I connect this carbon to this alpha, I will have 1, 2, 3, 4, 5, 6, 7, 8. Tell me, 6-membered ring is more stable or 8-membered ring is more stable? Which is more stable? Ma'am, how will I decide if it's intra or inter? That you will see from the question itself. If there is 2 carbon within the question, That means it is intra. Okay? Tell me. Intra is preferred over inter, if intra is possible. Right? If intra is possible, in other cases intra was not possible. That's why we did inter. Right? 6-membered ring is more stable, no? So that means this point is useless here. And this we will not do here. So what we are going to do, we're going to connect this. So I'll make now 1, 2, 3, 4 here. Right? Let's make this is 1. No, let's make this from here. It is 1, this is 2, this is 3, this is 4, this is 5 and 6. So you make a 6-membered ring. Because eventually a cyclic ring it is forming now. It is forming a bond here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's how I have made a 6-membered ring. 6-membered ring you have. On the first position, what you have? You have a C double bond O that is converted to OH. Then you have a methyl group here. Right? On this is, let's say this is 1, this is 2, 3, 4, 5 and this is 6. On the 6th position you have C double bond O CH3. Okay? After this, alpha beta. This is alpha and this is beta. I'll just write it from here. This is alpha for this carbonyl. This is alpha and this is beta. Elimination will take place here. Right? So what will happen? This is the cyclic compound. Here you will have methyl. I'll just write it like this. This is double bond. This is COCH3 that is formed here in the end. Right? Okay. Tell me. Okay, everybody? Tell me. Okay? Now let's talk about Cannizzaro reaction. Wait a minute. COCH3 double bond O and this is this. Yes. Okay. Then let's talk about Cannizzaro reaction. What is Cannizzaro reaction, guys? In this case, you don't have any alpha hydrogen. That means Cannizzaro reaction is going to take place. And here you use concentrated alkali. You use concentrated alkali here. Right? Okay. Now see this. One molecule of aldehyde is reduced to alcohol. Another is oxidized to carboxylic acid salt. This is a very simple. Very simple. You will find it like, ma'am, that's so simple. Right? So here, if you have self Cannizzaro, with the same number of carbon, you will form an acid. And with the same number of carbon, you will form a alcohol. Right? Okay? Same number of carbon. This is like here CH2OH is used and here COONA is also formed. So same number of carbon, acid and aldehyde is alcohol is formed. But the question is, ma'am, when we have cross Cannizzaro means this kind of situation, two different compounds. Now, which one to convert to alcohol and which one to convert to carboxylic acid? That is the question, right? So, very simple thing you have here. All you have to do is, acid will be formed to that where aldehyde, which it will approach without any hindrance. That means less steric hindrance, you can write. And more steric hindrance will find alcohol. So if you see this over here, which one has less steric hindrance? This has less steric hindrance, so its acid will be formed. its acidic salt is formed. This has more steric hindrance, so its corresponding alcohol is formed. Okay, so what we have is less steric hindrance and more steric hindrance concept. Here if you see, here it is less steric hindrance, so its acid is formed here. Here tertiary one has more steric hindrance, that is why its alcohol is formed. CH2OH, its alcohol is formed. Right? So just remember, less steric hindrance means acid is formed there. Right, everybody? Now let us see this question. Identify the reagents that is used for the following conversions. Let's see that. You will see chem catalyst Diksha, you will be able to find it. Right? Okay, everybody, let's see this. Now, here what you have, identify the reagents used for the following conversions. Now, here what you have this compound A that I don't know, but definitely I know one thing, that it is converting this ester to CHO. This A is converting ester to CHO. I don't know if you remember this or not. Ester to CHO was Dibble. Dibble. It is there in the options. It is Dibble, Dibble here. So first two options are already eliminated because ester to, if you want to convert ester to aldehyde, then Dibble is used. Now what is this B? Is it NaOH or is it NaOH alcoholic? Let's see. If you use dilute NaOH, then definitely there is going to be aldol condensation that I can see over here. Can't you see intermolecular aldol here? We can see this over here. This will be what will happen here. I'll just show you that how intermolecular aldol will be there. See. If you see this here, this is C double bond OH. This is CHO. What will happen? This is alpha, na? These two will link together. This will be converted to, I'll just tell you what is formed here. This is OH as it is. This is 5-membered ring. Then this CHO will be outside. This will be converted to 1, 2. On the second you have this. On this you have C double bond O. That is converted to OH. Okay, after that elimination will take place. This is alpha. Wait a minute. This is alpha, this is beta. Yes. This is alpha and this is beta. Elimination will take place and here you will have the formation of double bond O. So this is double bond CHO. This is carbon, carbon. Next to this you have CHO, CHO. Right? Next to this you have double bond, double bond. So that means they are talking about aldol condensation only. So this is aldol condensation. In aldol you use dilute NaOH, not alcoholic. Wait a minute. Alcoholic they are used now. So next will be C will be, wait a minute. Next will be, you have NH2KOH, that is ethylene glycol, or this. We are saying that even OH is converted. Now COH is converted to this. Even OH is being converted to this. OH is a sensitive group to acid or bases. It is sensitive to acid now. That means we are using Clemenzin reduction here. That means D is going to be the correct answer. Fourth is going to be the correct answer here. Right? Okay. And alcoholic NaOH is what? From this also it is clear that base in presence of ethanol. Okay. That gives aldol. Right. So it is already clear from there. Right. So answer is fourth is the correct answer here. Right. Okay. Now you have a few. Wait a minute. Let me just see what all we are left with. right? So I'll just complete it till carboxylic acid and then I'll give you the break. Okay? Yes, everybody. Now let's do some special rearrangements that you have. Right? Some special why the students are not there? Where you have gone, guys? Sleeping? Those who promised me to be here till the end. I already told you the marathons are long, huh? So the challenge is never easy. If I tell you we'll teach you 3 hours a day and your that will be completed, that is a lie, right? So marathons are not easy. You have to promise yourself, right? Okay, tell me. Cross Aldol to we did na. Huh. Let's see Bachmann's rearrangement. These rearrangement na, they are not there in your NCRT. So those who are preparing for board, they can skip all of that. Those who are preparing for JEE Mains, JEE Advanced, they must do this. All topics are covered. That's why this much time I'm taking, right? So the acid catalyzed transformation of an oxime to N-substituted amide is known as Bachmann's rearrangement. Right? Let's understand what is going to happen. And it's not difficult, it's easy only. Just relax for some time, right? You will find it easy. See, you have R dash C, this is ketone, this is NH2OH. So what you have is, this will be eliminated. You will have the formation of C double bond O NOH. You have oxime. Now what will happen? In this oxime, you will have the rearrangement. How rearrangement will be there? One of the alkyl groups that will shift here, right? So what will happen? You will have R C double bond O, one alkyl group. This will be C double bond O. And then next to it, you will have nitrogen. This will be C double. Next to it, you will have nitrogen. And then this R dash will be attached. I know this is now what has happened. So let's see the mechanisms. Here, mechanisms will make it easy for you. The rearrangement is catalyzed by a variety of acidic reagents such as H3PO3. All these are dehydrating good agent. Right? Mechanism is that you have this oxime, then you add H positive here. What is going to happen? This H positive will be attached here. This will be O positive. Now what will happen? Any alkyl group will be shifted here. This alkyl group will shift here to the nitrogen, and what you will have R dash. This is carbon, this is double bond nitrogen. This will already be eliminated from here. R dash carbon double bond nitrogen into R. Into R, I am saying bonded to R. All you are doing here, guys, what I am doing is, this is attaching to this side. This is H positive. This will be eliminated and this will jump here. This will become R dash C double bond N R, right? That is formed here, right? Okay. Already rearrangement has taken place. Now let's see, because you have shifted one alkyl from here, there will be carbocation. When you attach H2O, it will attach OH here, OH2 here, this will be positive. Then this will be eliminated from here and this will shift here and you will have the formation of OH. Now you have R dash C double bond NR, right? Now let's see. These are, if you see this here, this hydrogen is eliminated here, this bond is shifted here, and this bond is again shifted here, right? That will form R dash C, this is double bond O, this is NR, this is negative. To this negative, you will attach this H. This is the mechanism. Now, if you're finding the mechanism difficult, I'll give you a simple thing here, what you have to do here. This is the oxime, right? What you do, this is RC double bond O, right? Next to the double bond, you will have NH and alkyl group will be there. RC double bond O, right? If you have seen the mechanism, it will become easy for you to remember this. RC double bond O, then NH, the alkyl group that has shifted. Okay, that is Bachmann's rearrangement, right? That is called as Bachmann's rearrangement. In this reaction, the group which is anti to OH group migrates. Which group will migrate? The one that is anti to OH group, right? So whichever group is anti to OH, that will migrate. This is anti, that will migrate. This is anti, that will migrate. Okay? Right, everybody? Now, if you see this here, now I'll tell you how to answer the questions here. See, anti to OH, you have CH3. So what you will have C6H5, C double bond O. This is NHCH3 because CH3 will migrate, right? Here, what is anti to OH? This is anti to OH. So you will have CH3, C double bond O. This is NH, and this group will migrate. This is C6H5. So that is the answer. Okay, tell me. Is that clear? Yes. Guys, tell me. Do you want me not to teach this? Tell me. Do you want me not to teach all these reactions? Do you want me that I should teach you essay? That this also we have done, this also I should lie to you? If that is a big chapter, it will take time, isn't it? Ma'am, when will the session end? When will the session end? Can't you see? Now I'm not going to answer these questions here, right? Okay? Focus. When someone is teaching you, learn, right? I have never asked my teacher these kind of questions, never done that, right? So please, that irritates the teacher as well, right? Even I have my personal life, but still I am here, right? 6 a.m. in the morning, we are taking classes. Whether it's 11 p.m. or 1 a.m., we are taking the classes. It's not because it is benefiting us. It is not benefiting us. We are just doing it for you, so that those students who rely on us, those students who were waiting for this, because time is less, we want you to utilize your time properly, right? Now see this. Perkin reaction, when aromatic aldehydes like benzaldehyde is treated with anhydride in the presence of sodium salt of acid, we get beta unsaturated, alpha beta unsaturated. Let's see what is there. So what you have, benzaldehyde is treated with anhydride. This is anhydride. What you get here, this benzaldehyde is converted to CH double bond CH, this thing is added here, right? That's it. Just remember this, that you have CHO where you add this CH double bond CHCOH. That is Perkin's reaction. Okay? When you have benzaldehyde is treated with anhydride in presence of sodium salt of acid, we get alpha beta unsaturated acid is we are getting there. Mechanism and all we will not do here, right? That is not important for you. Just remember, by knowing alpha beta unsaturated acid, we can get the idea about anhydride used in the Perkin's reaction. This can be done by keeping H at the end. So I'll just tell you one step of this mechanism, why we are saying this. So whatever is the anhydride, that anhydride, this is the anhydride now, that anhydride will make the anion, and that anhydride will act as a nucleophile. It will attack here. These lone pairs are, these pi bonds will jump here. This will form CO negative, CH2COO, COCH3. That is formed here. Again, what will happen? You have BH, that is base is added here. So base is going to give you H positive here, H positive it will give here. Then again you add water here. Now water, and in the acidic condition you add CH3COO. H will be abstracted from here. And now if you see one thing. This is, wait a minute, this is OH now. CH2, this is CH3, COOH, right? That will be done now. So that's how in the end you will be left with this thing. CH2COH. CH2COOH. This particular part will be taken out here. So you'll be left with only CH2COH, and after that alpha beta unsaturation will take place. This will be the thing. But here all you have to remember is that alpha beta unsaturated compound is formed. This mechanism, they will not ask you this in JEE. That I am 100% sure, right? They will not ask you this in JEE. For JEE, you don't need to take this much load here. For JEE Advanced, you can do this. That also mechanism, this mechanism, okay, but you should know this. For Advanced, you should know this, but for JEE Mains, you can skip this, right? Okay. Now next is benzoin condensation. Now, when the ethanolic solution of benzaldehyde treated with a strong alkali potassium, the benzoin is obtained. Benzoin is alpha hydroxy ketone. It is a coupling reaction between two aldehydes. So what you have here, you have two aldehydes. They are coupled together. One is OH and one is C double bond O. So you have C6H5, C double bond O, H. This is C6H5, C double bond O, H. This is converted to OH. This is converted to the same thing, and a coupling reaction is there. That is called as benzoin condensation. Okay? Yes, everybody? Tell me. Mechanism and all you don't have to do for this one. Okay? Next is benzyl-benzylic rearrangement. This also for JEE Mains, so you can skip this. So I'll just delete this part, right? JEE Mains, so you can definitely skip this. It's not even in your syllabus, right? Okay, so you can skip this part. Benzoin also is not directly in your syllabus, but these kind of PYQs we have seen. That is why I'm not skipping it. Perkin condensation also you can skip if you want, right? Okay, but just remember this one. Okay, just remember this condensation, that is Beckmann's rearrangement. Okay, that you must remember. Otherwise, all the others you can skip, right? Now let's talk about electrophilic substitution reactions that are there, right? Okay. Now what I am doing is useful. Okay, benzoin, you can remember what is benzoin. Perkin, you should know what little bit idea what is happening. Beckmann's you should know, right? That also they can ask you from exam if they want to ask you a tough question. But otherwise, it's rare chances are there, right? More chances are of Aldol, Canizaro. These questions are more important for you, right? As compared to benzoin, Perkin, these are like least priorities. If you want to skip it, you can, right? Okay. Now, this is something which is important, that if you talk about carbonyl group, they are deactivating and meta-directing. That I told you that always with the benzene ring, when you have a group that is connected to a double bond with a more electronegative atom, that shows minus M effect. That is why it is deactivating and meta-directing. So always the substitution is going to happen on the meta position. If you see electrophile, that is electron loving. So electron density is more at the meta position. That is why you can see this from the resonating structure as well. It is more at the meta position. That's why meta products will be given. For example, in nitration, you have meta product. In this also, you have meta product. So meta products are formed here because it is meta directing. Okay. Next, guys, we have the distinguished test here. If you see the distinguished test over here, test for aldehyde and ketones. Shifts, I told you, it is pink color, it has no color. Fehling, red precipitates are formed. Tollens, black precipitate or silver mirror is formed. Sodium bisulfite, we told you that crystalline compound is formed in case of aldehyde. In case of ketones, colorless crystalline compound is formed here. Both the cases it is there. right? It is given by both aldehyde and ketones, right? So these are the distinguished tests here, right? 2,4-DNP, what happens? Orange, yellow or red well-defined crystals with melting point characteristics of individual aldehyde, well-defined melting point individual ketones are there, right? Then a deep red color, because this is also given by both aldehyde and ketones. Then sodium nitroprusside and few drops of sodium hydroxide, it gives deep red color here, and in this case it gives red color which changes to orange color, right? And here formaldehyde does not respond to sodium. This is in the practical chemistry as well. This is there in the practical chemistry. Okay, so that's why. Chalo, now let's talk about some questions here, guys. Let's do some questions as well now. Right, everybody? Let's do some questions here. Ready? Tell me. Let's do some questions, students. Shall we do? Right? Let's do some questions now. If you see this over here, this is metachlorobenzyaldehyde on treatment with 50% QH solution yields what? See, metachloro, it's quite a simple question. You know, in JEE, these are your PYQs only. If you see, these are your PYQs and these kind of questions they ask you. So when you have done all that I have taught you, you will find it very easy. So this does not have any alpha hydrogen. So it is going to show you Cannizzaro reaction. Cannizzaro reaction. Guys, Cannizzaro reaction means one will be one will be alcohol, other will be acid. So that means chlorine to will remain same. Na? At the meta position it will be. This is, so 2 is the correct answer here. Because chlorine will not change. Wait a minute. If you have 50% this, then chlorine also will get changed to OH. Because KOH you have, na? So, 50% QH, Cannizzaro reaction, it will show. QH. Okay? So, answer will be second is the correct answer here. That is Cannizzaro reaction. Now, let's talk about, let me see others. Okay, CH2, CO negative. Okay. Yes. The product of the following reaction is P. Now, they are saying the product of the following reaction is P. Number of hydroxyl groups in P. Let's see how to solve this. If you see this particular reaction, this is negative, this is positive. This is one major mistake that students do is, they think that it will react with CHO, but this reaction will not take place because this is only one equivalent, Grignard reagent. Grignard reagent shows you two kind of reactions. One is Grignard reagent, when it has a proton source, it will accept H positive and it will give MgBr. Second is it will show nucleophilic attack, right? But here OH is being more acidic in nature, it is going to show reaction of proton source, how it reacts with the proton source. So how it reacts with the proton source? CHO is going to remain as it is. This is going to become OMgBr, and here to this phenyl you will give it, one hydrogen. That means benzene will be formed. This phenyl will have hydrogen. This MgBr will be attached here, right? So this is a very important question. This is your JEE PYQ only. Now if you see, this is again with aqueous NH4Cl. This is again converted back to OH. So this is the reactant only. Here you will not calculate OH because this is not a product. This is reactant only. This and this are same. This is not considered as product. This is the product P. and it has 0 OH. So no OH hydroxyl group is there, right? Okay, 0 OH is there, right everybody? Yes. Is that clear? Right? Okay. Is that clear? So those students who are asking me, ma'am, how many questions from this chapter, trust me, even in exam, na, when you pick out the exam, you will also find difficult that which question you should give to aldehyde, which question to ketone. Some are mixed questions as well. So that's why in organic chemistry, I never say which has high weightage. Every chapter has high weightage. You never know. Last year they focused on hydrocarbon. This year, in shifts also they variate. In some shift they've asked all the question of alcohol phenol. In some shift they ask all the question of aldehyde aldehyde ketones. Right? So that you have to see. Acha, now next is okay. Few questions I'll do now. Identify the name reactions here. So as you can see, benzene to benzaldehyde and COHCl, that is nothing but that is Gattermann-Koch reaction. So third is the correct answer here. Next question is, acidity of alpha hydrogen of aldehyde and ketone is responsible for aldol reaction. Statement 2 is reaction between benz and ethanol will not give cross aldol. That will give cross aldol, benzaldehyde and ethanol, right? Because ethanol has alpha. Acidity of alpha hydrogen of aldehyde is responsible for aldol condensation. That is also true, right? So both the statements we can say. Why second is not true? The relation between benzaldehyde and ethanol will not give cross aldol. Like cross aldol, too many products it can't give. It will give actually aldol only, not cross aldol. It will give aldol. That is true. It will give aldol. Cross aldol means both should have alpha hydrogen. But you can't say it will give Canizaro. It is giving you aldol only, but cross aldol it is not giving because this does not have alpha hydrogen. Right? This has alpha hydrogen, so it will give only aldol, right? Not cross aldol. So answer is wait a minute. Benzaldehyde and ethanol, one does not have alpha hydrogen, other has alpha hydrogen. No, I was right. Huh? One has alpha hydrogen, other has no alpha hydrogen. So it is cross only. No? Two different products are getting reacted. Yes. Why I'm getting confused in that? Yes, two different products are getting reacted. So that will definitely give aldol. So that means this is the incorrect statement. So first is correct option. My bad, my bad. Right? I answered correctly, then I answered incorrectly. Oh God. Right? Let's see the next one here. Right? Identify the product in the following reaction. So now this is the reaction. You have to identify the product. It is zinc amalgam HCl, that is Clemenzin reduction. So whenever you have Clemenzin reduction, what you're going to do, this will be converted to CH2, this will be converted to CH2, this will be CH3, this will be CH2, CH3. So first is the correct. In fact, you know, I don't know here, na, same it is, I would just write it like this. Okay, so A is the correct answer here because both of them will be converted to CH2. Okay. If the number of the correct reactions among the following is, now number of correct reactions among the following, if you see this is H2PD, say this should be converted to CHO, so this is incorrect. This is COHCl, and here number of correct reactions among the following, this is not correct. Gattermann-Koch reaction, it will give CHO, right? This is CO. With hydrolysis, it will give you not amine, that is also incorrect here, right? If you see first one, that is going to form this carbonyl, that is going to attack here, so it will be C double bond O. So this is also incorrect. So only one correct reaction is there, right? Only one correct reaction is there, that is C, right? C is the only correct reaction. Okay, this is not written here correctly, right? First is not the correct one, because here you will have the formation of CO benzene and it will be attached CO benzene, so it will not form CH2. It would have been CH2 if it would have been this Clemenzin reduction you do, and this is the correct one. So answer is C is the correct answer. Okay. Next is identify A in the following reaction. Now you have Wolff-Kishner reduction. Wolff-Kishner reduction. In Wolff-Kishner reduction, what you do? You replace this C double bond O with CH2. That is fourth is the correct answer here if you see. Right? CH3, CH2, CH2, CH3. Fourth is the correct answer. Right? Now let's see this particular question here that says only few 3-4 questions we have. After that we are going to start with carboxylic acids. Okay, then carboxylic acid is a very small part, so don't worry about that. It's a very small part only in the Claisen-Smith reaction. Now this reaction now you might find it difficult, but actually it's quite easy only, right? So let's do that. Shall we do that, everybody in the chat box? Yes. Firstly, Claisen-Smith to prepare dye. What they are saying, reaction to prepare this Claisen-Smith reaction. This is important. Now I'm writing what is this reaction. Okay. So here, benzaldehyde you have. Benzaldehyde is reacted with C double bond O, CH3. This is a very simple reaction actually. It's a very simple reaction. 2 times aldol will take place here. 2 times cross aldol will take place here. What will happen here, right? This C double bond O will stay as it is. Here, this C double bond O, if I write, this is C double bond O, H. This is also written as C double bond O, H. And here if you write, I'll just write it as CO. Okay, I'll just write it as CO. I'll just write it as CO, CH3. Now, this is also alpha, this is also alpha. So what will happen? This carbon will be connected to this one. This carbon will connect to this one, right? This will be converted to OH. So what you will have here, right? What you will have here, this, that you don't have to convert to OH, right? Okay. Beta, just wait for some time, no? Huh. So here what you will have, this is benzene. Beta, nobody is forcing to you to be here, right? You can go if you want to go, right? So this is CH2, this is C double bond, this is CO, this is CH2, this is again benzene here. But here if you see, that thing, wait a minute. C double bond ho na, Claisen-Smith reaction will have to add it there, right? Huh. C double bond it is there. Wait a minute. I did it little mistake, right? Wait a minute. Let me just write it like this. Okay. This is C double bond O. This is H. And here, wait a minute. This is C double bond O. This is H. And here it is C double bond O, CH3. This is CH3. This is again, this is benzene. Firstly, the reaction also you need to know. Then after the reaction, you need to apply stoichiometry here. So this is benzene. This is C double bond C, C double bond O, C double bond C. This is benzene. It will be formed. Okay, by this it will be easy for you to form C double bond C, C double bond O, C double bond C, C double bond O. Right? Okay, now you can complete the hydrogens here. That is, one will be here, one will be here. I think 1, 2, 3, one will be here, and one will be here. Okay, that's how you write it. Now this is the product that is formed. Now they are saying in the Claisen-Smith reaction to prepare 351 of this. So they have given you calculate the number of moles of, let's say this is X, right? Using 83 gram of acetone. We know that how much acetone is required is the amount of benzaldehyde. See, simple thing is, guys, very simple it is. I'll tell you how to do this. Acetone, firstly, you know, this much gram of benzaldehyde is to prepare this much gram of benzaldehyde using 87 gram of acetone. So either from acetone you can choose or from this you can choose. One thing we are sure about, two things are given to us. You can calculate the number of moles of this one or calculate the number of moles of acetone. Double always will be the number of moles of benzaldehyde. And then multiply it with the weight and then you will get your answer. I'll just tell you how. See how we will do this. Firstly, calculate the number of moles of product that you have. If you talk about, in this case, it is 234 is the mole. 234 is the molar mass. So number of moles of product, if you see, that you will find out to be, this is 351, this is 234, right? Okay, after calculation it will be 1.5 more. I am not wasting time on that, right? Once this is 1.5 mole, double of it was required. If this is 1 mole, this is 2 mole, this is 1.5, this will be 3. So we know that number of benzaldehyde is nothing but that is 3 mole, right? So weight of benzaldehyde will be 3 moles into molar mass of benzaldehyde. Molar mass of benzaldehyde you can calculate, and the molar mass of benzaldehyde is coming to be 106. So you can put it here, 3 into 106, and that will be your answer here. Okay, this I applied the stoichiometry. This reaction you need to know. After that everything is easy only, right? Okay, sure. Now, which among the following aldehyde is most reactive towards nucleophilic addition reaction? The one which has most electron deficiency. You can see this over here. This has most electron deficiency. So this is most reactive towards nucleophilic addition reaction. Then there comes this question, that is match list 1 with list 2, right? These are all the tests and these are all the identifications that are written here, right? So you can see this over here, and I think this, so you can attempt yourself as well. Beer's test is given by Beer's reagent is for unsaturation. Ceramic ammonium nitrate is given by this alcoholic OH group. Phthalate dye test is given by phenol. Now most of these tests, if you see alcoholic and phenol test, we have not discussed here. Unsaturation test we have not discussed here. So those who have not done hydrocarbons and alcohol phenol, they won't be able to attempt this, because this we have not discussed, right? Okay, we have only discussed this Schiff's test that is given by aldehyde. So these two, right, that we know from aldehyde ketones. Others are alcohol phenols, and unsaturation test is there in hydrocarbons. Identify the major product X formed in the following reaction. So again, it's quite simple. So major product formed here is what? Gattermann-Koch reaction. So here it will be benzaldehyde is the major product here, right? Okay. Again, what you have, bromine water test, ceramic ammonium nitrate test, ferric chloride test, and 2,4-DNP test, and their identifications here. So this I am giving you for your homework, right? Because this is all cramming based. There is nothing to teach you here, right? Next is, which of the following will give silver mirror test? Now this is important. Silver mirror test is given by not ketones. It is given by aromatic, aliphatic, and also formic. So A, B, C will give you this. So answer is A, B, C. Right? Understood now? Tell me. Tell me everybody. Now we are going to start with carboxylic acids. Right? Okay. Now we are going to start with carboxylic acids. Right? Okay. Tell me. Shall we do this? Or do you want any break? Tell me, do you want 5 minutes break? Then we can start with carboxylic acids. Ma'am, how formic acid? I told you this in Tollens reagent. Hemiacetals, alpha hydroxyketones, formic acid, they all give you Tollens test. Okay? Okay, now we are going to start with carboxylic acids. Tell me, everybody. No break, only focus. Chalo, we'll start with carboxylic. After 30 minutes, I'll give you the break, right? After 10-15 minutes, I'll give you the break, right? So, structure of carboxylic acid, if you see, right? It's already 11:20 now. At 11:30, I'll give you the break. At 11:30 p.m. I'll give you the break for 10 minutes. And after that, that will be the final break. After that, we're going to complete the chapter itself. Right? Okay? Yes. So, if you see the structure of carboxylic acid, in the carboxylic acids, right, the bonds to the carboxylic carbon line in one plane and are separated by 120 degrees Celsius. Why? Because this is also a sp2 hybridized carbon, that is that is trigonal planar. Is less electrophilic. If you say why they are less electrophilic, because already there is one R group, that is then carbonyl carbon, because of the possible resonance structure that is there. If you see this here, right, this is C double bond O, this is O negative, and it is already showing you resonance. So because of this resonance, this carbon is not that electron deficient as compared to this your aldehydes and ketones, right? So fatty acids are higher members of aliphatic carboxylic acids, right? Monocarboxylic acid like RCOH having one carboxylic group also is called as monobasic. That means when you have one carboxylic group, that is monobasic, two carboxylic group is dibasic, right? Dicarboxylic acids are which have two carboxylic groups. They are also called as dibasic, right? And their oxalic acid is one of the example. Three carboxylic groups are tribasic, and citric acid is one of the examples, right? Now, naming of the carbonyl groups, you can see some of the very famous names of methanoic acid is also called as formic, ethanoic is called as acetic, propanoic is called as propionic, butanoic is called as butyric, right? Okay, tell me. Done? Okay. Acha. Next is derivatives of carboxylic acids. So the OH of an acid can be replaced by Cl, OR, NH2 group to yield acid chloride of an ester or an amide. These compounds are called as functional derivatives. For example, if you talk about all these compounds, right, this is acid. When you replace the OH group with any of the other group like Cl or CH3CO negative or OCH3 or NH2, different derivatives are formed, right? Like you have, this is acyl chloride, COX. This is amide, that is also derivative. This is ester. This is anhydride, which is COOCOR, that is anhydride. So these are all the derivatives of carboxylic acids. Okay. Now let's do the preparation. Let's do the preparation of, here most of the reactions so we will do in the next class only. I'm just going through this. Yes. Okay. Just chalo, I'll give you now break. Okay. Now we can have the break. Right? Okay, everybody? Yes. Now you can have the break. Just give me a second. I'm just giving you break now. Just putting some slide here for your break. Wait a minute. Wait a minute. By mistake, it is done. Just give me a second, guys. Wait a minute. Okay, so I'll just give you break ऐसे ही. I was just doing something, but I'll just give you break now. Okay? Right, everybody? Clear? Now I'll just give you break and I'll see you after some time. Right? After 10 minutes, I'll see you all. Right? Hello, yes, everybody. Let me know in the chat box if I am clearly visible and audible. So, students, let's do last part of carboxylic acids, right? Do let me know if that is clear. Let's start with the last part of carboxylic acid. Okay, this is the final part and it's a very small chunk. So, let's do that. Let's start with this. So if you, in most of the reactions you will see are repeated only, right? Controlled oxidation. Firstly, carboxylic acid is prepared from controlled oxidation of alkene. So if you have ethane and you add CH3CO twice manganese acetate, then you are going to get ethanoic acid here. That is, controlled oxidation means we don't want to convert it into carbon dioxide or water. We want to stay till carboxylic acid. That's why it is considered as controlled oxidation. Then next is from the alkenes. If you can see, if you remember, this all we have done before as well. Today only I have told you this, that in alkene, if you have very strong oxidizing agent, you will end up preparing the carboxylic acids, isn't it? Do you remember? We have done this today only, that if you have a strong oxidizing agent, you will prepare ketone. If you have very strong oxidizing agent, you will end up preparing carboxylic acid. So this is about that. Then ozonolysis of alkene also we have seen, that when you have oxidative ozonolysis, this is a case of oxidative ozonolysis. Oxidative ozonolysis. In case of oxidative ozonolysis, you will prepare what? You will prepare this carboxylic acids, right? In alkynes as well, when you have oxidative ozonolysis, you will end up preparing carboxylic acids. These all are the reactions of alkynes and alkenes that we have discussed today only. Then there is alkyl benzene. This is a very important reaction that says aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzenes with the chromic acid or acidic or alkaline KMNO4. So whatever alkyl chain is attached here, that alkyl chain, whether it's this or this, that is directly converted to COH. This is a very important reaction. And here, the entire side chain is converted to carboxyl, irrespective of the length of the side chain. But the condition is that side chain don't has to be tertiary, it has to be primary. That is the only condition for it, right? Then you have hydrolysis of alkyl halide. Now, if you have, let's say, these are the alkyl halides that you have. Then you add NaOH aqueous, that is going to replace halogen with OH, right? So you'll have 3 OH. Now, carbon cannot handle 2 OH. You're talking about 3 OH. It will not be able to handle it. So this will be eliminated, this will be eliminated, and here you will have a double bond O, and hence it will be converted to RCOOH, right? Okay. Then there is a question that is from Grignard's reagent. This is a very famous reaction, very famous reaction. So many times this has been asked, and such an easy reaction this is. Grignard reagent, this is positive, this is negative, and here this is partially positive, this is partially negative. This is going to attack here, electrons are going to jump here. So what you will have here, you will have C double bond O, you will have O negative, this will be R, this is MgX. Now this MgX will be on hydrolysis, will be converted to OH, that is nothing but RCOOH. Same thing, same attack, like just in Grignard reagent that we used to do before, same thing we are doing here, right? Okay, that is the example. R is nothing but now CH3 here, so that is CH3COH you will have. Same thing it is. Cyanide hydrolysis, you have C triple bond N, right? When you do complete cyanide hydrolysis, that is converted to carboxylic acid. When you do partial, this is a very important reaction, very famous reaction. I'll just mark it. Very important reaction for your exam point of view. because these we usually ignore these reactions, but they are asked in the exam, right? This is partial. This is partial hydrolysis. And this is complete hydrolysis. This is complete hydrolysis. Partial hydrolysis, you have the formation of amide. Complete, you have the formation of acid. Okay, everybody? Understood? Right? So here it is, complete hydrolysis. You have this group is replaced by CONH2, is group is replaced by COOH. Right? Then there is alcohol oxidation. Oxidation. Now tell me, if you oxidize alcohol, that is converted to aldehyde or ketones. For conversion of it to carboxylic acid, you need, if you want to convert 1 degree to carboxylic, do you remember we have done this? 1 degree to carboxylic, you need only strong oxidizing agent. For 2 degree to carboxylic, you need very strong oxidizing agent. 3 also you need very strong oxidizing agent. Okay, so these are the oxidizing agents. But when I talk about primary with alkaline KMNO4, it will work. But if you have, let's say these are all primary only, but if you have, that's why here, if you Jones reagent is strong, these are all strong oxidizing. These are not very strong oxidizing agent. You are not heating it and all. If you have 2 degree or 3 degree, you need to have very drastic conditions to have carboxylic acid. Do you remember I told you also how to prepare it? In the starting, in the very starting of this reaction, in this of this session, I told you how to prepare carboxylic acid from 2 degree and 3 degree as well, right? Then there is aldehyde oxidation. Aldehyde, directly you will have mild oxidizing agent also that will convert it to carboxylic acid. So any oxidizing aldehyde, this with a mild oxidizing as well, they are converted, because the chain is, you have alkane, then alcohol, then aldehyde or ketone, then you have carboxylic acid. Now aldehyde to carboxylic acid, even mild will work. So any reagent like Tollens, Fehling or these reagents will do its work. But if you have ketone, like for example, you have this condition, you have any oxidizing agent, whether it's mild or strong, it will easily convert this to carboxylic acid, because you just going one step ahead. But do you remember when we were using very strong, when we were using strong oxidizing agents, ketone was not getting converted to COH. Only primary was getting converted to COH. That means for ketone to carboxylic acid, mild will not work. You need very strong oxidizing agents, right? Ketone to this, you need to, this is now ketone to this, you need very strong oxidizing agent, only then that can work. Then there is next thing, that is methyl ketone on oxidation gives carboxylic acids, right? Methyl ketones like this, they will give you carboxylic acid. This is a very famous reaction, that is iodoform reaction. This will give RCOONA, right? And CHI3. This CHI3, this is iodoform reaction, from where methyl ketones are going to give you the oxidation. Here this specific reagent is used, that is NaOH-X2. This is haloform reaction only, right? Okay. Whose birthday is this? Happy birthday, Harshvardhan. Happy birthday. God bless you. May God bless you always, right? So now let's see this. This is methyl ketone. You have iodoform reagents. Then this is going to form PHCOONA, and this is going to form CHI3, that is going to give yellow precipitates, right? Then hydrolysis of any acid derivatives. All the acid derivatives that you have, acyl chloride you do hydrolysis, it will give you back carboxylic acid. Any acid, any derivative you have ester, you have amide, you have acyl chloride, you have anhydride, it is all going to give you acid. all the acid derivatives on hydrolysis gives you acid, right? Okay, that was about the preparation. Now we will do physical properties, then we'll do chemical properties. Let's see. Let's see the physical properties here. What are the physical properties? Physical properties are lower fatty acids up to C10 are colorless liquids. Higher ones are colorless waxy solids. First three members have sharp pungent odor. Rest of them has rancid butter, where higher members do not possess any smell. Right? These are all the physical properties which are not asked ऐसे तो, right? Now if they ask you, I can't say anything, but usually they are not asked. But melting boiling point is important. Lower members are highly soluble. This is important, that lower members are highly soluble in water, but solubility decreases with the rise in molecular weight. Just like in aldehyde and ketone, it is inversely proportional, right? That is important. Then melting point of carboxylic acid with even, this is very, very important. This point is very, very important, okay? This point is very important. Melting point of even number of carboxylic acid is higher than odd number of carboxylic acids, right? Such effect is observed in the first 10 members of the homologous series. Even numbers will have more melting point as compared to odd numbers, right? Okay. Then carboxylic acid exists in dimers, as you can see this here, because of very strong hydrogen bonding, and they exist in dimers in the vapor phase, or in the aprotic solvent they will exist as dimer. It's not like always they will exist in dimer. In the vapor phase or in aprotic solvent they will exist in the form of dimer. Boiling point of carboxylic acid are higher than those of alcohols of same molecular mass due to inter. Now if you talk about boiling point of carboxylic acid are higher than those of alcohol, because here they have dimerization is existing here. In alcohol also there is H bonding, but dimerization is not there. So that is the reason, because of dimerization they are even stronger intermolecular forces, and hence they have very good hydrogen bonding, right? Next guys, we have chemical properties. Let's talk about the chemical properties here. Let's talk about the chemical properties. So many properties you have seen here, right? Let's talk about that. Thank you. Now for that, have you also liked the session? But I see you guys praise me a lot in the chat box, but I see comments you don't do. And that hurts me a lot, right? In chat box, so you just you're like, ma'am, you're the best, this and that, but also write down it in the comment sections that after the class also I can see that, right? So chemical properties, first is acidic nature of carboxylic acid. Carboxylic acid dissociate in water to give resonance stabilized structure. As you can see, whenever good acid is the one that after losing H positive has a stabilized carbon ion. So after losing H positive, this is a carbon ion, and you know it is even more. Now you will say, ma'am, it has, ma'am, resonating structures, right? As you can see, it will shift here, this will shift here, this will shift back, this will shift back. But ma'am, phenol, ma'am, it has five resonating structures, and this has only 2. So phenol is more acidic. No, this has equivalent resonating structure. That is why this is more acidic as compared to phenol. Okay, remember that, right? Carboxylic acid are weak. They are weak than mineral acids, but they are stronger acids than alcohol and simple phenols. They are stronger than simple phenols and alcohols. Remember this point, right? Then acidity of carboxylic acid is this. I have already told you why this is stable, because of equivalent resonating structures. Because of equivalent resonating structures, they are stable. Okay, right everybody? Acha. Now let's see this thing. Whenever you have any electron withdrawn, this I told you in GOC as well, whenever you have a carboxylic acid, you take out the electron from there. Whenever you have a carbon ion, you take out the electron. It is going to do what? Whenever you take out the electron from the carbon here, the stress, carbon ion means stress. So when you decrease the stress, it will become more stable. So its acidic strength will increase. When you donate, it will be like, I am already under so much pressure, you are giving me more stress, it will become destabilized, so its acidic strength will decrease. Right? Right? So order of effect of group in the effect of the group in the acidity, in the increasing acidity, that will be this, because they have more minus effect. Electron withdrawing effect decreases in this range. That is why acidic strength, the way to make it more acidic, also decreases in this range. Right? Now you have electron withdrawing group stabilizes the anion and hence increases acidic nature. As you can see this over here, this has maximum electron withdrawing nature, so it is making it maximum acidic. Here electron withdrawing nature decreases, so its acidic strength is also decreasing. Because just remember that acidic strength is directly proportional to electron withdrawing group, inversely to electron donating group. This is what you have to remember. Right? Electron donating groups, if you see, they are going to destabilize. Like here you have no plus I effect. Here you have plus I effect of this one. Here you have two plus I effects here. So it is going to destabilize. Right? Electron donating group is inversely proportional to acidity. So it is going to destabilize it. And that is why this is the thing. Right? Okay? Acha, this though is a part of apna your GOC only. So I will not do it here. I have already discussed that in GOC. Okay. So now let's discuss this. How do you add nucleophile in the carboxylic acid? When you add the nucleophile over here, right, this will jump here in the same manner. You will have a nucleophile and you will have the leaving group here as well. Right, this is the same thing. Loss of leaving group, then the leaving group will leave from this side and this will again jump. And you will have this. Right? So nucleophile acyl substitution takes place by addition elimination mechanism. If you see this here, firstly we are adding the nucleophile. We are adding the nucleophile, then the leaving group is leaving from this side. This leaving group can be anything, right? This leaving group can be anything. It can be Cl, it can be NH2, it can be RO, it can be RC double bond O. Anything can be there, right? So firstly, what we are doing, we are attaching the nucleophile here. You have this thing. Now, but just this leaving group, if this is OH, this nucleophile attacks here, this leaving group leaves here, right? This nucleophile will, this L can be anything. We are talking about all the derivatives of carboxylic acid, whether it's amide, ester, anhydride, acyl chloride, anything. It is going to attack. Electrons are going to shift here. This is O negative, right? Okay. And then leaving group, whether it's OH, NH2, that is going to leave here, right? And that's how you will have your answer, right? Nucleophile acyl substitution takes place by addition elimination mechanism, right? That is addition elimination mechanism. Firstly, we add nucleophile, then we eliminate leaving group, right? Whether this or this is eliminated depends upon the relative basicities, right? So weaker base is preferential eliminated. The one that is weaker base, that is eliminated because weaker base is the better leaving group. This is very important line, that weaker base is a better leaving group. The one that is a weaker base, that will be eliminated. Right? Okay. Incoming nucleophile should be stronger base than the group so that it can be replaced. So it is a simple thing. If I say incoming nucleophile, this is the nucleophile, this is a weaker base. So nucleophile will be eliminated because a weaker base will be eliminated. A weaker base is a good leaving group. If your nucleophile is a weak base, then it will be eliminated again. There is no use of doing that reaction. So when this nucleophile that you're adding, it has to be stronger as compared to this leaving group. So always remember, this nucleophile has to be stronger as compared to the leaving group. Its basicity has to be in this order. Only then this reaction can take place. Right? Okay? Right, everybody? Do let me know in the chat box if that is clear. If you see towards nucleophilic substitution reaction, what is the order? This is the order. First is acyl, then anhydride, then ester, and then you have amide. Okay, this is the order of nucleophilic substitution reaction. Right? Okay. Okay. First thing is the reaction of acyl chloride formation. So what you have an acid, you place any hydrogenating agent, PCl5, PCl3, SOCl2, it will replace OH with Cl here. Simple, right? Okay. Then if you talk about Fischer's esterification, if you want to form ester, then you have carboxylic acid with alcohol, OH and H will be eliminated and you will have the formation of ester here. This we have done already so many times. That's how it is done. These are the examples. CH3, COO, CH2, CH3 is formed. Ester, even here C6H5, C double bond O, OCH3 is formed here. Right? Okay. Then reduction to alcohols. When you want to reduce it to alcohol, you need a good reducing agent. But remember that we can't use NaBH4 here. That is a very important point. Reduction depends upon the nature of reducing agent. So if you talk about with LiAlH4 in ether solution or BHTLF or diborane, etc., these all are useful to convert monocarboxylic acid easily to primary alcohols. This is important and this has been asked so many times to you. So mark it very, very important. Right? Okay. So if you see this hydrogenation, this is directly converted to 1 degree alcohol with the same number of carbons. But this line is so important that NaBH4 will never ever do this. NaBH4 will not reduce carboxylic acid. NaBH4 is never going to reduce the carboxylic acid. NaBH4, from this question, the difference in LiLH4 and NaBH4, they have asked already so many questions in your PYQs, you will see. Right? They will give you certain reaction. They will give you with LiLH4, this product is formed, with NaBH4, this is formed. In LiLH4, carboxylic acid is reduced to alcohol. In NaBH4, it is not reduced to alcohol. Esters can be reduced. Acyl chloride can be reduced, but carboxylic acid will not be reduced. This is a very important point. So next is again a very important reaction, that is Hell-Volhard-Zelinsky reaction. Here alpha hydrogen atom is replaced by halogen. So what you do? This is alpha hydrogen. It is replaced by halogen in presence of X2, that is your halogen, in presence of red phosphorus. Right? This is an important question. If you see this over here, consider the following reaction. Everybody see the following reaction over here. Tell me. If you see this over here, you have CaCO3 that is going to, this to we will not do. है ना, this is already not in your syllabus, so I'll just delete this, right? Okay, rest of the reactions will do. Let's see. Malonic acid derivatives. So this is malonic acid which has two COH, and this is CH2. When you heat it, it is going to directly give acetic acid. So when two carboxyl groups are attached to same carbon, that is geminal carbon, that is malonic acid. Decarboxylation takes place simply on heating. You heat it and you will have the decarboxylation here, right? Okay, yes, done. That means this one CO2 will be eliminated here. ठीक है, हाँ, ethanoic acid, you can say acetic acid, that is common name and that is IUPAC name. Beta keto acid, how they are formed? Beta keto acid means this is acid, this is alpha, and on the beta position you have keto. Beta keto acids are unstable, and that is the reason they are going to give you directly ketone by decarboxylation. Again, decarboxylation is going to take place of beta keto acid just by heating them. Just by heating, right? Just by heating, it will decarboxylate. Here, because on one, they both are unstable. Here on one carbon, you have two COH. That is unstable, so that's why on heating, it gives off carbon dioxide. This is also unstable, right? That is why this gives off carbon dioxide by just heating, right? Then there is soda lime decarboxylation. This so we have used even in alkane parts, right? That here, this CO, you have sodium salt, use CaO and NaOH, that is soda lime. This will be eliminated and you will have the formation of RH. Right? Okay. Similarly, you also had Cole's electrolysis where RR was formed. If you remember, you had Cole's electrolysis as well where RR was formed. Right? Okay. Then Hunsdiecker reaction. What is there here? When silver salt of monocarboxylic acid, it reacts with Br2 and CCl4. It releases carbon dioxide. It forms CH3Br, that is formed. It forms AgBr here. Alkyl halide is formed. That is also a decarboxylation reaction. You have done this in haloalkanes, halorenes. You have done this in that preparation step, right? Okay. So what it is going to give you? It is going to give you, if you see, a carboxyl radical is produced in two-step process, right? Chalo, that though, I'll just... Then there is Schmidt reaction, right? Carboxylic acid reacts with, this is hydrazoic acid, right? This is hydrazoic. This is different reaction. This you must have not done. I don't think so. You must have done this before carboxylic acid. In carboxylic acid, if you're doing this for the second, third time, then you must have done this. This is hydrazoic acid. When it reacts with an acid, right, in the presence of sulfuric acid, it is going to give you amine. RNH2. That's it. Again, decarboxylation is there. This will be eliminated and here NH2 will be attached here. So RNH2, primary amines will be produced. Primary amines with one carbon less than the parent chain is formed. This is important reaction, right? Okay, done. Then let's talk about reaction involving proton. When protons are replaced here, so any acid you have, any metal you use here, it is going to replace this proton with the suitable metal. Okay, with the metal that you have used, it is going to replace it. Right, everybody? Then reaction as an acid, how it is going to react as an acid? Tell me, how it is reacting as an acid? What an acid does? Acid, when it always, an acid has this property. Acid on reaction with bicarbonate or carbonate always forms its salt plus water plus carbon dioxide. So its salt is what? RCOONA is the salt of carboxylic acid. So this is the property of acid only. And they are giving the property of acid because they are also good acids, right? Weak than mineral, but they are good acids, right? Then acid chlorides, how it is prepared, right? You use PCl3, PCl5, SOCl2, you have the formation of acid chloride here. OH is replaced by Cl in all these cases. Acid anhydride is prepared by, you have two acid molecules and you take out water from here, you will have the formation of acid anhydride. Or you have one acyl chloride or one acid, then you take HCl and you have the formation of anhydride. Okay, so that is how anhydride means, by elimination of water only it is formed, right? Okay, yes everybody. Acha, now let's talk about ring substitution. 2-3 more reactions we are left with, right? Ring substitution. Tell me, what is ring substitution? Ring substitution, carboxylic group acts as a deactivating and meta-directing. Now that I told you. Why it is deactivating and meta-directing? Because this benzene, whenever you have a group that is attached to an electronegative element, it always shows minus M effect. Minus M effect means deactivating. For minus, M means mesomeric, but here whenever someone shows minus M, it is meta-directing. Plus M means whenever you have benzene and the group is connected which is having lone pair. So this is always deactivating and meta-directing. COH also. And that is the reason you use nitration here, right? You will have the meta as a product. You do bromination, you will have meta as a product. Now, important thing is, aromatic carboxylic do not give Friedel-Crafts reaction. Now, this is also a statement-based question can be asked, why they don't give. Because the carboxyl group is deactivating and the catalyst aluminium chloride is Lewis acid gets bonded to the carboxyl group. AlCl3 will get bonded to this COH here, right? And that is the reason Friedel-Crafts acylation or alkylation is not shown here, right? Okay. Then there is Claisen condensation. Here what happens? You have an ester, right? You add ethanol, sodium salt of ethanol here, and you add ethanol here, right? What will happen? R, this is C double bond O. Again here what you will have? This is R, this is same C double bond O. Again you will have this R, again C double bond O and C2H5. Okay? This particular thing here is added. RC double bond O, right? RC double bond O, RC double bond O, OC2H5, right? Mechanism and all you don't have, right? So directly you should just know that what is this reaction, what is happening here. At this point, what you add here, RC double bond O. This is added here. Rest of the things are same, right? Okay. Chalo, now let's do some 3-4 questions here and then you are free to go. Right, everybody? Let's do. Let's see if you can answer these 3-4 questions or not. Acha, see one thing. Identify product P in the following reaction. This is HVZ reaction. So alpha hydrogen will be replaced by bromine. So answer is going to be A is the correct answer, isn't it? Yes. Isn't it, everybody? Let me know if you can answer this or not. Now let's see the next question here. Let's see the next question, everybody. Next question is your PYQ. That is, major product B of the following reaction has how many bonds? Pi bonds. See, this is the alkyl. You will see the reactions. It's not very tough questions are asked. Very simple questions are asked. This is, you just have to know the, you just should have the knowledge of reagents here. This is alkyl part. Whenever you have KMNO4, this is converted to, I'll just write the pi bonds here as well. This is converted to COOH. Okay. Then on the addition of this nitrating mixture on the meta position, you will have NO2. So now if they're asking you the pi bonds here, then how do you answer? This is N. This is also 1 only. Okay? Wait a minute. Let me just draw this more neatly. Meta, this is N double bond O, this is N, this is positive and this is negative. If you see how many pi bonds are there, 1, 2, 3, 4 and this is 5th. So 5 pi bonds are formed here. Right? Okay? Right, everybody? Ah, I see you guys have totally, ma'am, please you only solve, ma'am. We to can't, ma'am. Ma'am, we are today dead, ma'am. Totally dead now. So this is a very important question. Very, very important question. And these kind of questions can easily be repeated as it is. No, I am little bit tired, but it's okay, right? Acha, now let's see this. Right, everybody? Let's understand what you're going to have here. So you have, this is benzene, right? And this is a compound that is having, not like this, this is a compound like this, C double bond O, and this is OH, this is O, it's like this kind of compound you have, and you have AlCl3. You know what is the first thing that comes in my mind? Can I show Friedel-Crafts acylation here? This is like an anhydride. Anhydride, this is C double bond O, O, C double bond O. Anhydride can show Friedel-Crafts acylation on benzene. So that means what I'll do here, I'll break any of this bond you can break. Let's break this bond, right? If this bond I'll break, this will be positive. That will attach here. So how do I do it? If this bond I'll break, this is double bond O, this is double bond O, this is positive, this is O, this is negative, right? This is going to get attached here, so this will be C. This carbon is going to get attached here. This is C, double bond O, right? This is 1, 2, 3, 2, 3, right? 1, 2, 3. This is again C double bond O. This is OH. Isn't this what you're going to have? Tell me. Are you able to understand how I formed this? What I did is, I converted this thing to double bond O, this is double bond O, this is O. I break this bond and I converted this to negative, this to positive. Then I reacted this on the benzene ring. So this particular carbon attached here, C double bond O, this is 1 carbon, 2 carbon, 1 carbon, 2 carbon. Third carbon has double bond O, O negative, double bond O, O negative. And this, where the benzene, where on the benzene ring where this carbonyl group has attached, it will have a hydrogen. That hydrogen has placed here. That hydrogen I have placed here, right? Okay. So now let's see next what we are going to do. Now this we have done, AlCl3 that we have formed. Next is, this is Clemenzin reduction. So in Clemenzin reduction, first step was only little bit confusing, otherwise so it is simple only. You can see this over here, this is converted, this is converted, this is converted to O. No, this will be as it is. Because acids are not converted to CH2. This thing is converted to CH2 in Clemenzin reduction, zinc amalgam, right? Then concentrated H2SO4 means you are going to dehydrate it. This is dehydrating agent. So how do you solve this? Dehydrating means here also you will have hydrogen. OH negative will be taken from this side and H positive from this side. These two will get attached and here you will have one, two, three, 1, 2, 3. This double bond is as it is and here this will be attached. Right? Let us see again what if you have done something or not. No. So what you have done here, you have the preparation of chem. We can clearly see A is the correct answer that we have formed. Right, everybody? Tell me. Remove water from here and that will be the correct answer here. Right, students? And that's it. And we have completed our session successfully. And before going ahead, before moving, one important thing for all of you, that tomorrow in the morning also you have Namrata ma'am session, and also in the description box you will see this Eklavya rank booster test series that is available for 2026 students at just 999 rupees, which is at 80% off right now. And here you are getting 11 part syllabus, 25 full syllabus test, and along with that you are getting 93 high weightage topics. Apart from these 36 tests, that is full like mock test, you're getting 93 high weightage topics test. Based on the topics you will have the test. Okay, that thing will be there. Okay, and also from here, clicking on this, you will have, you can ask your doubts, you can ask anything from here, your doubts, your PDF, everything will be available over here, right? Even you can take the quizzes based on this particular lecture. You can have the quiz based on this lecture, right? Okay, yes, students. So that's it for today, and I'll see you all in the next class. Till then, bye-bye. Take care. My class is going to be now on next Monday, and I want to see all the comments in the comment section what you want me to take up, right? I have already decided a little bit, but I want your opinions as well, so that if some plus minus I can do, I'll do, right? Okay, chalo. Okay then, guys. Bye-bye. Thank you everyone. Now I want all of you to write it down, your comments in the comment section, because that is what makes me feel happy that okay, if we are here for 6.5 hours, if we are teaching, then you are also appreciating us, right? Okay, don't be confused, write it down in the comment section. Bye bye everyone.